All right. Hello, everybody. Tonight is the 1st of December for Dallas Personal Robotics Group Virtual Builders Night Out, or in, as the case may be. And I hope everyone had a great Thanksgiving. So tonight we're just going to do our usual silliness of going around the table and talking about what we did, what we wish we would have done, what we tried, and what crashed and burned, and whatever little gauntlet or mitten talk comes up for our forthcoming contest. Always a fun thing. So with that in mind, let's just dive right in. And Doug, Doug D, would you care to describe the challenges you had to focus on robot stuff in the last week?
Yes, I did several things. I was trying to get this RCWL0516 microwave, not sure if y'all can see that, a microwave sensor working. And my first time playing with a breadboard, so I actually got it up there and I can make it turn the LCD on. But when I tried to hook it into the robot, it's just kind of dangling right here right now. I didn't have as good a luck, so something's wrong in my wiring, and I'll work it out. It's just, I also had a lot of work to do this week, so I didn't get as much work on the robot done as I had hoped. But it kind of works, but it acts like it not sending out the full amount of signal. And the first one, when I plugged it into the robot, it heated up the USB port really bad. So I thought, oh, there's a short or something in there. So fortunately, I bought multiple of them, of course. They're cheap. And I just switched to another one. It worked a lot better. And so that was that. On another note, I'm going to share for just a second because y'all were always so interested in how my home robot could be kicked over and killed by intruders. And I thought that I would take a moment to say, I'm not the only one with the idea. You can probably see this Lynx robot from Amazon on my screen. And look down here. He has a surveillance mode where he can protect the house. So I thought that was pretty cool. Of course, another thing about him is, oops, if I get out of that, not currently available because apparently they sold it out and they don't want to be back in stock. So maybe it got kicked over too many times. Who knows?
Well, maybe, Doug, there's like an open carry feature for that robot,
Could be. I'll talk about that in a couple of weeks about open carry. Robots can be dangerous, especially if the programming doesn't work good. So that, I think, was all I had. Oh, the other thing I did accomplish was I'd intended to make the communication between my Raspberry higher intelligence part of the robot and the Arduino motor control and sensor control part of the robot through serial. And that worked out as easy as I'd hoped it would. So that's going to be the method I use. You just plug a USB cable between the two and open the serial ports, and they just talk automatically almost.
Also, Doug, there's another robot out there. If you look up Misty Robotics, like MISTY, it looks very similar to that Robbie Senior you have there, but it's different. It's the same kind of statue there, but they've been pumping them in the Microsoft world for a while now. And they're like, hey, let's give you a really great deal on this thing if you want to develop on it and all these kind of things, right? Man, for $3,500, I just don't have laying around. So,
whoa,
but it's a nice thing. I've met the people building it. I've talked to them a few times, but they do very similar things as well. And in fact, they want people to write skills for it. And one of those skills is to walk around and recognize people and do things because it has a bunch of stuff already on that thing.
Yeah, that would be fun. You're going to have to bring that price down and make it marketable.
Same here.
Yeah, with a robot named Misty, is that a family-friendly robot?
Yeah, it's not one of these. It's not one of those real doll robots that you've probably seen on the internet somewhere. No,
Well, my thoughts are, since Amazon has been trying to compete with me on my home autonomous robot, I'm going to sell out to them at some point. Even though I'm posting it all in my blog and it's free, but I'm going to trick them into paying me for it. That's my grand plan. Oh, now that I've said it out loud, they'll watch this video and it's all screwed. I'll turn the floor over to somebody else now.
Question, remind us what you're doing with the radar. That was a radar you said you tried out, right?
Yeah, this was a microwave.
A microwave
control sensor. So basically it detects motion at about 15 to 20 feet, and it does it 360 degrees, and it does it through plastic and possibly walls. So basically it's a motion detector for the robots being still and waiting for something to happen in surveillance mode, and it'll look, something's moving around the house. I need to pay attention.
But you haven't gotten it to work at all?
Right. I've seen 3 or 4 videos on the internet about how to do it, and I've almost got it working, but not. I can't plug it into my robot and have it do what I want to do yet. But I'll get it.
I had tried one of those. I think you got someone you might remember. I had one. It lasted for about a week before it burned out, and then when I contacted them, they said, "Well, it costs like $10. It's your problem."
Yeah,
that one went through walls, actually.
Yeah. They talk about it being very good. It's just, I got 5 of them in this packet. The first one, like you say, burned out quick. The second one sort of worked for a minute and then quit working, and I don't have a lot of faith in them.
Yeah, I put a link in the chat to that Missy Robotics thing I was talking about.
Oh, good.
They have an extremely short lifespan.
Oh, and on another note, that book that I bought turned out to be a pretty good book. It's very interesting. The one downside is that the companion website is down, so you can't use their simulator. But it's still interesting talking in the book. Lots of good theory.
Maybe that, I know it. So maybe you can dig it up through the Wayback Machine or some web archive. I wonder if there's a way to dig it up, or
right.
I don't know if you tried Googling.
And it wasn't in the Wayback Machine, but there's several things that do that. Mostly I was thinking, the book itself is useful. I don't know how useful the simulation would be. In the book, they keep saying, oh, try this, and this is why this is doing this. So it would help you see what they're talking about.
Right.
Oh, yeah. Ron Dag spoke up with a simulator the other day built on Unity. See if I can find that here right fast.
There's some cool stuff built on Unity, the game engine. In fact, just as a crazy side note, if anyone has seen the Star Wars Mandalorian on Disney, if you go look for the extra footage where they have the behind the scenes stuff, somewhere in the technology episode, they describe this thing called the volume. And it's basically a stage that is pretty much 360 degrees of high density LED screen. So what they do is they virtually model the sets that they want to film on, and then they put motion capture on the camera, not on the actor, but the camera. Well, maybe they have it on the actor as well. And then based on that, because they know the camera angle, that wherever the camera looks, they have the motion capture on the camera tied into the Unity game engine, which then changes the display of the room on the soundstage, all the walls and the ceiling.
Wow.
So it gives you real front light perspective of if you had a camera there, and if the background with that kind of field of view, and if the background was Tatooine or wherever it is, and the person was standing right here with respect to your camera, that's how it would look, reflected light and everything. And so that's the cool thing. They've tied a soundstage with basically 360 degrees screen wall to motion capture on the camera and the Unity game engine to perspective correct everything. It's really fascinating to watch after you see a few of the episodes. But
yeah,
I put well, first of all, if you're watching it, I just have one word, Ahsoka. But anyway, I did put a link to that Unity blog that has a simulation in there. Basically, if you're doing ROS, you're doing ROS stuff, it can take one of your universal description files as a YAML file and process that, and you give it a. I took like 2 minutes to read the thing, so it's probably more complicated than this. But you take that description of the robot that you already have to build for ROS, drop it in this processor, and you give it some environment to play in that will then know how all the mechanics and stuff are wired together, or kind of the idea of then putting your robot in the 3D space and mucking around with it and that kind of stuff. Looks pretty cool, but ROS by itself is a dive. It is jump into the deep into the pool. It's all of this stuff, and yeah.
Well, cool.
Figured I'd share.
Harold, while you're on stage, do you want to you want to walk through what you've been doing this week?
Sure, I can keep doing here. Let me. I will tell you, I did get my Teensy into going pretty good. At least I blinked an LED on it by the, because it's different. If you've not played with a Teensy before, it's an Arduino, but it's not an Arduino. It's an Arduino to the fact that you can code like it's an Arduino, but how you load images and that kind of stuff on it, it's a little bit different way of loading things. But they have this thing called a Teensy Arduino that you download it, install it, it adjusts your IDE to do all the right things for you. It's pretty cool, and it worked a lot easier than I thought it was going to be. The big problem I have on that is that all my Fermata stuff that I was using to drive my robot around to have it play with and be nice with it, doesn't work on Teensies because the architecture changed and the Fermata guys don't know how to compile for that architecture. So
Bummer.
Yeah, bummer. So it looks like but I found this other thing called ROS2 Arduino, and it's using a protocol that, see if I can find it right fast. Arduino.
Isn't that called ROS serial or something like that?
There is ROS serial, and they also use something called Micro XRCE DDS. Micro XRCE DDS. And it's a protocol for talking that.
You're doing ROS 2 then. You're doing ROS 2.
Yeah, I'm doing ROS 2.
Okay.
And so I'm running on that, and I'm like, okay, I don't know what that is, but it says I'm supposed to use it. So we'll figure all that out. And I hadn't figured all that out exactly yet. So in the meantime, what I have been doing, besides my cat over there, I have been, I got to go to a formal event. So I 3D printed me a
bow tie,
triangle bow tie, and I'm going to paint this red and green. And that kind of got the idea from the wife of painting. So if you look down here, remember that white mask with the eyeballs and all that sort of stuff? It is no longer white. I have painted it up.
cool.
The eyeballs and stuff are there. See if I can turn off the light so I can get you some better eyeballs if you can see them. And I got a little blue light over here, which is giving me some problems because I can't access the GPIO for some reason. But I have enabled the joystick so I can make the eyeballs look around with the joystick. And if I click, I blink his eyes.
Very cool.
And that sort of thing. The only real fail so far with this, besides not being able to access the GPIO as expected, is I was picking up the colors. I was picking up the colors and I found some of this. I'm like, how cool would this be on the face mask, and creepy could it be, right? I put 2 coats or 3 coats of this because it's clear on top of it after I painted 3 or 4 coats of all these other colors. I'm just painted the mask. Guess what doesn't glow?
My guess would be what you painted.
Yeah, what I painted. Exactly.
Hey, Harold, there used to be one question that I haven't heard you mention that just comes to mind is, have you ever considered mounting that thing on the front of your robot?
No, I have thought about that kind of thing, right? But this is a project I started going on it. I'm actually going to. If I do, I'm going to do something different.
You could name it Misty.
Because Misty, exactly. I'm going to do something a little different because I want this to be a part of my stream. So I've made the determination that much like Jedi Knights who have to build their own lightsaber, aren't really Jedi Knights until they build their own lightsaber. I think that if I'm going to be a Twitch streamer until I code up my own Twitch bot, I'm not really a Twitch streamer. And so my idea is I've got a speaker here in my Magic 8 box that'll plug directly into the Raspberry Pi. The Raspberry Pi already has things that I can download that will do text to speech. And I was watching some people writing some bots the other day. Seems pretty straightforward. And I figured I could make a thing where you go bang and say and give me a little bit of a text string. And I take that and have this thing talk to me. In fact, this blue button here is going to take over the Magic 8 box thing with on the blue button that I've got on there to have it speak and say stuff randomly. And then write me a text box where people can talk things and maybe make the eyes look left or right, or possibly even change the eye color and eye style if I get around I know there's some other images out there that will make different eyes that are already out there. I just got to go pick them up and drop them in the right place. And so, but another thing is if I ever go back to work, this will probably go with me to work just so it's creepy. And I'm thinking that if I mount like a little bit of a camera right here, or maybe make a hole and mount a camera here, and as it walks by, I might be able to, I have the eyes look like they're following you or something, or say something if it sees you more than once. Hey,
I was just gonna say that's what you absolutely have to do. You're gonna have to track, faces something. You're gonna have to make the eyes follow.
Yeah, make the eyes follow, and then maybe say something. I guess work appropriate, but still as they're walking by and doing things.
Well, I was thinking you could integrate an Alexa into it, right? If you do the camera thing, integrate Alexa, put it in your kitchen, and then see how that goes.
Yeah, we'll see how that happens. But anyway, lots of fun things from branching off. This is not what I started off to do. I wanted the eyes. I wanted to mount them, and then all the colors and all the other stuff. And this little bit over here where I'm messing around on this came up pretty good. I mean, the bottom plate was fairly simple to design, and I designed this plate here for holding it, and it includes a channel underneath for routing all this stuff, so it goes away. And not sure how well the speaker is going to fit or not, because I really didn't plan on putting that in there until way later. But I can always get a smaller speaker in there that does some stuff that will sound okay. It's pretty possible things. Pretty creepy, but it'll be all right.
It's very realistic, Harold.
What now?
It's very realistic. I mean, just by the eyes, it looks
I will tell
very
you,
impressive.
I will tell you, I am responsible, but not really responsible. The eyes and all that stuff are actually, if you get into here, let me find that link right fast, and I'll put it in there so that everybody else can play along with me, if you care. Let me go to the very beginning of all this. And yeah, that link is in there. Adafruit went so far to give me the base set of eyes, design them all out with the blinky and how it overlays with using Photoshop.
What is that from?
I had to make a trip
To Buc-ee's.
Yeah, I was driving for some reason, and it just happened my car went to Buc-ee's.
Where were you going?
Someplace. Yeah, maybe not. I'll take it back. Anyway, the wife is inquisiting about what I was doing today.
Yeah, we got that.
Yeah, and I'm like, none of your business.
No, it was the cup that you were drinking out.
Oh, I see. I gave myself away a bit.
Oh, that
That's
eye is a
good.
screen?
Yeah.
Harold, that's such an amateur thing to
Wow.
do. You don't give away with a cup.
I know. So, yeah, so each one of those eyes is a little OLED screen.
It's amazing.
That's all right. I see it now. She knows, and it's going to be even harder on her because I don't break. I don't tell people nothing. You know, it's only going to be harder on her. She knows how that works. But
This is like the detective novel when they strip the guy and find that in his pockets he's got a matchbook from the strip club or something like that. You
Yeah.
just don't do that.
Something like that. So, but anyway, it comes with a board, a hat that goes on there, plugs in there, and it comes with you can go download a Python, a bit of Python that does all those movements, and they got a bunch of algorithms in there for moving the eyes around. Like now I've got them static. So if I were to change this to do automatic, you'd see the eyes moving and darting all by themselves, and the iris is opening up and closing. And that little board that they give with you has 4 inputs on it, 2 of them for X and Y, a third for blinking of eyes. Oh, no, the blink doesn't go through that. 2 of them for X and Y, a third for the iris. So if you put like a photo resistor or something on here where it changes resistance, it's an analog input. So it'll make the eyes open and close depending upon the brightness that you're throwing in there. And that's just the base level stuff that comes in there. But anyway, that's what I'm planning on. That's what I did. That's, you know, so the realistic, you can see some of the blinky things that are going on, how it's got some realism to it. The eyes would move very realistic as well if I put it in auto mode. Yeah. So it's pretty cool.
Yeah, it's pretty wild.
Mm-hmm. And I would just love to build a big old tall robot and have some of these on it as the face at some point. That Misty Robotics thing I just pointed out there, how they do it, they just got a big screen. They just got a big screen with pixels that they draw eyes on and put eyebrows and all that kind of stuff for the emotive kind of things that are going on.
Well, see, even the robots you've been building, I mean, it could be Thomas the Tank Engine, right? Like, where just put eyes on anything and all of a sudden it's human-like.
Yeah, exactly. Lots of fun stuff, man. Lots of fun.
Cool.
Stuff.
Well, that's great progress.
Yeah, and the other thing, the robot, this thing here is still in pieces, but the motor controller is going in the right place. The Teensy's going to go in the right place, and I was able to blink it. So now I've got to do more research in ROS. So I guess I am going to get ROS going and put some joysticks on there and a few other things on there and see how that works. And that's about all I got.
Very cool. All right. So Mr. Jean, let's check out the order a little bit then from what we've been doing lately. How has it been going in Jean She-land this week? You just
it's good. I did so first I want to mention I got some good Pololo sales last week. I heard from Chris about this 3 degree of freedom thing. So actually today I was like, maybe it's ending. So I looked at their website and sent in 2 wishes, and they get back to me like in 2 hours, and so it's still going. Just want to let you guys know. I mean, when I got the coupon, it's like ending tomorrow. So if you want to look and put some wishes in, I think there's still time. I got like 50% discount, so pretty happy.
Yeah, I don't know if it was last year. They said the sale ended, and I thought it ended the end of the 2nd. It actually ended on the 1st. So I don't know if it's on tomorrow or not. You might want to check.
Well, I sent in some wishes like this afternoon after work, and like right before meeting, I got an email back, and I just checked it out. So it's I mean, I bought it. I
So
bought
you
it. with
submitted
the
your
discount.
order. Okay, so then you're good.
Yeah.
Yeah. Yeah.
So
Anyway,
yeah, before, pretty good deal. I'm really happy with the discount. Another thing I want to ask. So I got some simulation going on. I mean, I got some progress on the simulation. So I got some understanding. One thing I realized is, well, it's a simulated car, right? So I really know what's gonna happen. Like before anything happens, before I move anything, I know what will happen because it's simulated. So so now here's the question: how much deviation is allowed from the track? I mean, I want to ask Doug because that's kind of how I optimize it for. So is
No
that
deviation, I think, is allowed.
all right? Maybe he's not here, but anyway, so what I realized, yeah, maybe since I'm talking here, maybe I just want to share with you guys some of my understanding.
John, I think it's basically, I mean, it's one of those things where there's a judge's discretion, right?
Right. Well,
So to-
you can say it's a judge discretion, but a rule of thumb will help because it's like at the certain speed, the shorter I go, the faster. I mean, the shorter time it will be. So, say if there's a corner, right? Do I want to, curvature it inward? Like how far? I mean, it's really.
It's part of the game, Sean. Right? If you go take the S curve, from what I remember last time we did it, if you take the S curve and you fly straight through it with no visible intent to try and even wiggle a little bit, nah. Somebody that wiggles better gonna.
But the thing is, if I say, okay, the maximum error is 1 inch or half inch, that's a number I can use without any guidance. It's like,
that's a different contest. You gotta roll the dice and make your bet.
I'm pretty sure I'm off by more than 1 inch. Let's put it that way. Just show us your green breadcrumb trail, and then people can tell you if you're likely to pass or not.
Yeah. Okay.
This is peer pressure, John.
What I did, I haven't really run it, but what I did is I can say, okay, here's this sharp turn, right? How am I turning, and what's the shape it will be? Because I mean, it's a simulation. So yeah, one thing I did is I reconstructed this motion class because Ron's code is right there, so we can't access. Oh, that's wrong.
Hey, what are you doing?
Basically, you're not giving me the coordinate at runtime or computation time, but I can copy your code, so I always have that X, Y, and heading. But yeah, so I reconstructed that motion and basically the dynamics, and I can basically say, what if I turn this way? What will be my ending shape of my how the robot will go with the trajectory?
Well, I can give you a little hint if you want to follow. Well, if you call that curve as a depending on how you interpret it, but one way to interpret it is a sawtooth, because really, if you go from the center of each little island there, if you want to call that the line, then it's a sawtooth. Just the same as the 90-degree hard bend. You know what velocity the robot needs to have to do that perfectly. Mm-hmm. Anybody have a guess?
The maximum velocity.
No. No. The only way to make a perfect right angle turn is what forward velocity can the robot have?
Zero.
Zero, right?
Zero. Yeah. So technically, you'd have to have zero velocity. But it does get a bit tricky because you are dealing with a constant acceleration for both velocity and turning, and so therefore you have a bit of a problem to solve if you're really going for the optimal solution, because you can't, in order to start a turn of a given radius, technically you'd have to bring the robot to a stop. So if you want to perfectly trace, a straight line leading into a 90-degree arc, you have to stop the robot at the start of the arc, as far as I know, because you can't achieve that radius instantaneously. And it's kind of helpful, really, rather than trying to follow a line, just try to program some path moves, and you'll see how you have to wind into a turn. And I'm sure you can come up with an analytical solution for winding your robot into a turn with a constant acceleration rate. But
Yeah.
it is very helpful to do some pre-programmed moves.
Yeah, maybe I can share something. I did a simulation. Let me see if I can share. So hopefully you can see some of my curvatures here. These stuff.
Oh yeah.
I'll make it bigger. So what you guys see here is let me see.
Are those constant forward velocities?
So I mean, I don't really know what's the best way. But let me see, close all. Yeah. So this is okay. So going back to here. So my understanding is, if I know there's an angle, say 150-degree angle or 90-degree angle, I think the best or fastest way of turning is like maximum rotation, acceleration, and then turning halfway, the maximum deceleration of the angle. So it's going back to this zero rotation or zero rotation. Yeah. So with that, I get a bunch of like the heading degree. Let me think. Right. So this is like the rotation angle. I mean, if there's an angle here, right? So if I have 9-degree, like this 150-degree, and then I have a minimum distance. This is like with the vertex here, the distance to here, right? So I think at certain point, like you guys were saying, the judge will say, well, you're too far away from your desired trajectory. So that's this distance here. So when it's very small angle, it's almost tracking that vertex or very close to the vertex. But when I go to say 150-degree, it's like 9 inches away, which is too far. So I have to be slowing down to make the turn.
Right.
But I mean, I need to have put in a number. I'll put in 1 inch so that I can decide what is the
executive decision time. You got to make an executive decision.
I'll make a call. I was hoping that can give some rule of thumb here, but yeah. So, okay. The other thing I think present anymore. So the other thing I'm thinking is, I realize before I thought, well, how about I get a full image, right? Now I put these lines on there, and in a sense, I can tell the robot to sample any place. Like whenever it's my turn to control, I can put the sensor anywhere
Right.
and sample anywhere on the image, which is crazy. I'll just I'm thinking I'll just predict like two tiles ahead of me and plan my trajectory.
Oh, well, with that sort of well, technically the robot is, I don't know how clear it was made, but technically it sees a region, what it's about 12.5 inches square. It can see about little over 6 inches in front of the robot. So that's
true.
you could probably get clever and extend that a little bit, but I won't give away things.
What I find is, I mean, I can see further. this is what
I see a lot of smirking going on.
You can
anyway.
see into the future.
Well,
no, I'm not. Well, sounds
If you're-
smart, but
Since you're
yeah,
doing this analysis, what I'd recommend, and if I started down this path, and I hope I have a chance to do a little more of this, why not have some knobs available in your program that you can turn where you can set what error you're willing to accept. So in other words, have a knob on how much you'll decelerate or how closely you'll track, let's say, a corner. You know, what's the maximum error you're going to allow, or some number, I guess. You know, that might be something useful. And then if in the future, if there's some hard error, some quantitative error put on the tracking, then you'd be good to go.
Yeah.
And it would be fun. Don't you think that would be fun to have a knob that you could play with? I started playing with it just with the idea of winding into a turn, and I could sit there, and really what might be fun is rather than just run the turn trajectory, why not have the simulator run 10 trials? Oh, somebody's talking there.
Oh, you want to go down?
No, they don't want nobody in there.
Oh.
Sam's gone down with him. Shorty called Nikki. They won't want nobody in there.
Let's see. Who do we have to mute?
I told Nikki to call me.
Right there, that phone.
All right.
I think I can mute her. Did I do it? No.
Okay.
Hang on. There, I got her, I think.
Thank you.
So last thing I want to ask is, my understanding is, so right now there's a sample time. You have a sample time in there. I don't see any reason to tweak that sample time, right?
Well, it might be helpful. There's a minimum, and a minimum is 1/100th of a second. And of course, that's the sample time that would give you the least motion per update of your sensors. So really, I think it would make sense to use that minimum amount of time. I mean, somebody can correct me, but that way, I mean, it just depends on the geometry of your sensors. Obviously, if you had, let's just say, a simple horizontal sensor, in fact, Will, that's kind of was his original plan because that's what he has on his robot. But as we know, a simple horizontal sensor is likely to miss a 90-degree intersection. Hence, different sensor geometry makes sense. But certainly, smaller delta or step times help. But even though
so the snapshot is not missing anything.
Go ahead.
I'm thinking because the way when I'm controlling, I can read the sensor. I mean, I can place the sensor somewhere, read it, and I can place it somewhere else to read it. So what I'm thinking
next time step, right?
Well, no, not really. I mean, maybe it's something that you didn't intend to do. But what I'm gonna do is I have some rough sensors ahead, and just to detect new lines.
Right.
And then I'm gonna judge what scenario it is, and I'm gonna resample. I'm gonna resample and confirm.
You know, I'll have to take a look at that. It's possible. It was not my intention. So the original design of the simulator was one sample per frame, and technically that was not. If that's the case, it's not my intention to allow multiple samples. But I guess you discovered it. It's fair game. But I guess the idea was, well, hey, that's something maybe anybody can exploit then. Because
but you don't even have to exploit anything, right? You could just place a bunch of lines horizontally, closely. You know, you could build a camera, a 64 by 64 pixel, or any number of any resolution you wanted, right? You could build a camera and then there you go. You got access to as much information as you'd like. Don't have to exploit any inadvertent sort of, design features there in the code.
I agree, Chris. Yeah, so John, that's okay. If you can do multiple sensor reads, then that may be. Who's playing the piano?
Oh, my son.
Oh, that's fine. Okay, no. That's fine. I just thought it was, like something we could control. No. Anyway, hey, that maybe that's pretty cool, because if you think about it, like where Chris was saying, yeah, you could just define a bunch of sensors, but I have a feeling that if it will let you sample multiple sensor locations, that could be done a lot more efficiently. In other words, if you pop a scan line somewhere and you say, okay, I want to see 10 pixels, or some, well, it's in inches, I guess. Some inch.
Yeah, when I realized this, I say, wow, it's like I have the full image. It's just I'll just use what I want to use. So it's more like, well, I mean, if I one day I get this my own image sensor going on this simulator, I'll take an image, I'll sample some lines, and then I decide, oh, maybe I need to sample something else, and the image is still there. So in a sense, it is good. It's like the information, you got a snapshot of the image, you can do whatever you need to figure out, make a decision, and then go, right? And that may be an iterative process of where to read. Yeah. So anyway, yeah.
Hey, thanks for spilling that one. I'm going to take a look at that. I was late coming here, and I thought, oh damn, these guys are going to be talking about stuff, and I'm going to miss out, and I'm going to be in last place by the end of this. He who thought he was, touched by greatness will end up being crowned. Oh, and speaking of that, I have been working on a little promotional thing, but I had some, it's sort of an advertisement for LFS, but I was trying to come up with a caption, and I showed my wife, I had written a couple sentences, and she said it was too wordy. So here's my advertisement, and my monkey doesn't have a tail, and I know that. So I'm a Blender newbie hack. So I'll show you my advertisement. Let's see. Oops, wait a minute. See what you think about this.
Oh, that's awesome.
Does that make sense to people?
The monolith of it, I don't get, but.
Oh, so do you remember 2001?
Yeah, and the recent Utah.
Remember the monolith was sent down, and the monkeys, received information from the monolith that enlightened them. And so the idea was that's what LFS was there to enlighten you on, advancing. Maybe it would have been better if I was stuck with my original text, but anyway. But when Pam complained it was too wordy, then I decided I'd rip off the got milk, got monolith anyway. And also with that recent Utah monolith deal. Anyway, so.
Yeah, I'm thinking going on there, and I picked the wrong time to start rewatching all the Stargates series.
That's cool though. Nice graphics though.
Thanks.
Get the concept zeroed in.
Yeah, I know my monkey isn't terribly good. Oh, I can actually show you. I was inspired, so I decided I'd played with Blender like years ago, and that's one program that at least years ago I decided that if you didn't play with it all the time, you'd lose it all. I mean, I can get back up into SolidWorks or Eagle or any of those programs, and even if I haven't used them in 6 months. But Blender in the past, it was like, it was all hotkeys. But they've improved the interface. But I was trying to model one of I think they're monkeys, but maybe they're bears. I don't know what they are. They don't have tails. Maybe that's why but he was my my model for my Blender monkey, But then I had the DPRG robot, so that looked, that was a better model because that took some time to create. Anyway.
Looks good.
Yeah, thanks.
Yeah.
Yeah, that's an interesting program. I can see it can take years to gain expertise. I wanted to say I'm at the level of a 10-year-old with that program, but I would be insulting probably millions of 10-year-olds. Just blow me away with their.
So what's your latest time, Ron? Tell us about that.
I can't say.
We're getting into the secrets mode now.
Yeah.
Oh boy, we're zeroing in on them.
Jesse, what is he
Classified
here?
information.
Let's see. Jesse was on the. He's not here. I don't know if I know him, but he had done some work, and I think he had claimed some time for the simple course, the novice course. But I sort of said, well, we should avoid that because surprise, and I guess he was worried that he wouldn't be a good competitor. But my thought is, oh, come on, get out there and if you, especially too, if you have some different idea, even if you're not like low time, if you do something cool, I think that would be neat. Or you think up some interesting sensor geometry that minimizes the controller code or whatever, and even if it's not the fastest, I think you'd gain respect from anyone, really. So that's my words anyway.
Yeah, but it's cool. This Jesse guy you mentioned, it sounds like he'll be a competitor coming in join us from Iowa.
Ah, very good.
So he's going to submit a video, I think, and it sounds like he wants to compete in the line following as well. So that'll be good. Hey, Mr. John Kay, how about you? We keep it moving here.
I'll eventually get there. So I didn't really do anything other than I got the screws for putting this part together eventually. So I got some screw at the hobby shop, the super small servo screws. So hopefully this weekend I'll get to actually doing that. Other than that, I went and did kayaking this weekend. So that was it.
That's cool. All righty. Let's swing around. Go ahead.
It's too cold to go kayaking, isn't it?
No, it wasn't bad. The biggest problem was the wind because the lake was a pretty wide lake. So in the middle, it was sort of choppy a little. So mainly stay on the edge. But it was nice. It was around the 50 degrees, so it wasn't that bad temperature-wise.
Cool. All right.
Go underwater or not.
Literally cool.
So, Mr. Ray, how about you?
Well, I've been working on more or less a linear actuator. I added, I'm going to change this around here. Let's see if that's, yeah, can you see that? Maybe pin my resolution or something. Anyway, it's a right angle motor with a lead screw on it. I wanted to put an encoder on it, and I tried to couple it with a solid coupler, but that doesn't work that well. So I used the old rubber hose coupler, which works very well. It takes up, any misalignment you have between the shaft, either axially or radially. And it doesn't twist that much, so you don't really get off that far. As far as counts, I looked for switches because I want to take it down to one end and hit a switch, and then I know I'm at a certain position, almost like a homing, for the linear drive, and then I know it's 2,048 counts to the other end, and I can't go beyond that because it'll hit the motor. The nut will actually run into the motor housing. So I thought about storing the value in EEPROM because the Megas and some of the other processors have, you know, EEPROM in them, but that kind of assumes that you know, you haven't drifted or moved the thing in between. You know, if you just power back up and read the EEPROM and assume the thing hasn't moved, which it may have, you know, it could eventually get off and that kind of stuff. So had a little display to read out what the encoder count was. And there's a Mega with one of the what is that? VNH 5019 drivers on it. I don't know if you can see that or not. Anyway, so I actually ran out of switches on Tanner. Had to buy some at Palulu's sale. So Tanner's are no more. Can't go there and buy stuff. So anyway, did all my Christmas shopping at Palulu for myself, you know. But got one of the B&O 085s from Adafruit. I was actually looking for a pumped air respirator, but apparently you can't get them. I think they're being given to all the medical professionals. So to paint with spray paint, it's, you know, you have a pump and then 50 feet of hose, and it goes to either a half face mask or full face mask, but doesn't seem like you can get those for now, so I might have to wait on that. Just looking for end of the year kind of stuff. But so that's about it.
Cool. All right. So Murray, what's going on in your neck of the woods?
Well, as you may know, I had my robot into pieces for a while, and last week I got it back together again, and I've had to kind of back up a little bit on the operating system. And so I don't know if anyone here has ever used PyTest, but it's a Python library that basically scans the current directory recursively for anything named _test or test _, and then runs those as test files. And there's annotations and things. So what I've had to do is all of the basic functions of the robot I've been writing as tests in the form of PyTest, and then I can just write PyTest on the command line, and there's an INI file that it looks out on, grabs those, and runs the tests. So what I'm doing right now is going through all the basic functions and writing tests for them, because as I've learned in my normal real job, you know, software without tests, when stuff breaks, you don't know why, and it's always nice to have a test suite. So I'm kind of doing that. I do have a little bit of a new thing to report. Ray, you got that B&O 085, and I don't know if we can see that. Let's see. Can you see the robot at all?
No.
Just its mast.
The big difference is that on the front, on the top of the B&O 85, it's got a green LED.
Ooh.
Hugely important. But that's actually the B&O 88, and I've kept the libraries for the B&O 55 because those were quite complicated. I don't know if anyone's played with that thing, but it's got a lot of code behind it. It turns out that the B&O 85 is quite a bit different in terms of the libraries that are available on GitHub. And since I'm really only interested in the compass function, I've kind of been playing around with that, and I've written a test, and I've got it so that it basically takes the, I'm not a mathematician, and so when I get into the IMU stuff, it just kills me, but I've got it so it's taking the magnetometer and the gyroscope, and I'm using some of the code I had before from the B&O 55 to do quaternions, and then trying to figure out how to get compass points out of that. And I would say, and then what I'm doing is I'm taking those two outputs and then comparing it to the fusion output that you get from the compass part of the B&O 85. So I'm getting 3 comparative compass headings, unfortunately, they're never close to each other. I haven't figured that part of it out. So I'm spitting to the screen as I rotate the robot around, and I know where north is in my study, and I can't get this thing to even get close to what I was actually relatively happy with on the BNO 55, was that I could actually aim the robot at north or south, and it would give me a fusion output that relatively was actually quite accurate to within a few degrees. On the new sensor, I'm nowhere near there, and so I'm still playing around with that. It's considerably more difficult. So I can highly recommend the BNO 55, except for the fact, of course, it goes out of sync pretty quickly. The BNO 85, once it's synced, and it gives you I think it's a 1 to 5 value on how accurate it thinks it is to reality. And so, it actually comes out with an English, like almost, I can't remember what it says, but basically gives you a little phrase that says how accurate it thinks it is. And once it gets to medium, then you can kind of aim it, and it gives you numbers. Unfortunately, I can't get those numbers to match reality, so still playing around with that. Apart from that, I think that's about it. I've been pretty busy just kind of doing, like I said, all the PyTest stuff and getting the basics, the PID controller, all the sensors. I've got the 2 current sensors on the motors, and those work pretty well. The INA 260s. Basically, when the motors are running, you get a very accurate milliamp output from those sensors, and that's pretty good. So that works pretty good. I got one on the left, one on the right on the front motors. And I haven't put the fuse in, so if things go, it's going to go up in smoke, but living on the edge, apart from that, that's it from this end.
That's cool. Are you averaging the current readings on the 260s? Do you like take them over have a rolling average over time, or do you just look at instantaneous, or how do you interpret
No, I
those?
actually had figured out how to do rolling averages in Python. Basically, all I'm doing is taking all the sensor readings of in this case the current sensors, throwing them into a DQ, and then averaging the DQ, and then getting the output. And so I keep basically, and I can set the size of the DQ to either be, let's say, 5 or 10 or whatever. So I can kind of, and if the DQ is being populated at, let's say, every 5 milliseconds or whatever, I just set the size of the DQ, and that gives me how much time I'm averaging over. And then when I pull the average out of it, I can basically I can control the stability of that amount. And that's actually what I was doing also with the BNO 55, was that because it would bounce around a bit on where it thought the compass heading was, and I knew the robot wasn't actually doing that, I was actually averaging like over about, I think it was actually over 20 milliseconds or whatever, and that would give you a relatively fixed amount without all those spikes bouncing all over the place. So that, yeah, it's a good technique.
Nice.
Hey, Doug. Dowgen.
Yeah.
Which Intel RealSense camera did you have? Did you happen to have the T265?
I don't know because I can't find it. It's in my pile somewhere. It was one of the first ones, is all I remember. Right after they came out, I got one to do facial recognition, and then that didn't really work out, and I set it aside and can't find it.
Okay, all right. There's the T265 will actually give you kind of a map in 3D space. If you move it around, you can basically plot out where the sensor has moved to. What I'd like to know is how repeatable it is. If you get it exactly back into the same space, is it going to tell you that it is, that it actually thinks it's back where it started from? Or if there's, because it's doing things visually. So, it's kind of like the frame of reference is fixed. It's not going to move. But I'd kind of like to look into that. Has anybody else played with that camera or any of the other RealSense cameras? No?
Not yet.
Okay. Anyway, and then there's demonstrations of using the 2 cameras and doing SLAM. I think the D435 and the T265. But I'm thinking for a lot of applications, the tracking camera, the T265 would be great because, you get it back in the same position, it sees the same scene. It should tell you that it's exactly back to where it started with, angular orientation and, kind of XYZ in the space. So
You would think you could do that same sort of thing with OpenCV.
I don't know. I think you need two cameras though. Because I don't think you can get the angle as accurate if you don't have two. Because you could have a slight variation in.
Right. I think the things I've seen in OpenCV, they basically take what's the distance from midpoint and pretend to compute an angle. But you're right, it wouldn't be as accurate as having the binocular vision.
Right.
It's just, OpenCV, search on stereo OpenCV. There's some depth map. There's stereo binary, class reference, calculating a depth map from stereo images. So there's got to be a way to do it.
Yeah.
Oh, with the binocular camera, yeah. Yeah, I don't have one of those though. But yeah, it's it's kind of all done for you. The T265 spits out quaternions. And it does it at a pretty fast frame rate. I think 60 hertz. And if it can give you that good of positioning accuracy, okay, granted the BNOs are a whole lot cheaper, but if it works and it's repeatable,
and you got one laying around.
Yeah. Anyway, I was thinking of buying one.
All right. Let's see. Let's head west from New Zealand. So I think if we head west from New Zealand and maybe a little bit north, Chris, how's it going in your neck of the woods?
That's way west.
Good. Thank you. Question. Well, so I didn't buy anything from Polaloo. I was like looking through all the sales. The Three Wishes is always tempting, but I couldn't justify any purchase this time around, so I couldn't support their business, unfortunately. So, but they had to let a lot of people go, I think. So hopefully they stay in business. But I just couldn't find anything that I really needed this time. So now, quick question for Ron. When you're in contest mode, one thing I don't fully understand, even with the go and the stop buttons, I really just recently started using that feature. How does it know where to start? Because I guess it involves markers somehow, right? Because otherwise it just sits in the DPRG logo area and it uses that as the start location, but that's obviously wrong, right? So when you hit, run contest, how does it know where the start position is?
Well, yeah, that's a good. The method I use or have used since writing the markers is to place a marker and click on a marker. There is a facility where you can specify an initial position programmatically without markers, and it's probably still documented there.
But for the actual contest, how is this gonna?
Oh, well, I guess the idea would be to place a marker at however it's described. I think whatever the coordinates are, was it 4812 or 1248, something like that.
Okay.
So what you can do, the easiest thing I suppose to do is you could place a marker and then you could go look for the file and then clean it up if it's not positioned. Doug can answer that, I guess. Is it written that the robot must start at that exact location?
Yes.
Okay.
Yes.
Okay. So with that said, if you place a marker,
read the rules.
Read the rules. There you go. Easiest thing to do, Chris, is, well, me personally, rather than go try to write a marker file or whatever, just if you take the robot and click right on the start line near the center, it's going to be pretty close. And then if you exit, or you don't even need to exit the program, you just go to your data folder and look for the challenge contest course.mrk file. You'll see in there, and you can fix it up and make it just 48.0, 12.0, whatever, and presumably 0 heading, unless you want to start with another heading. I don't think that's specified. But anyway, 0 is along the line. Okay.
All right, good. Okay, good.
Yeah, and then so when the contest starts, the rules say, click your robot. It, then it puts the robot at that exact location, and then you press R for run. And then the only thing you can do, you can speed it up and slow it down. You can do time warp, on or off, but you're not allowed to. Pretty much, then the only thing you can do is space bar or the stop button or end or whatever it is will stop the robot.
Right, and then, but if the robot makes it all the way around, will it stop on its own when it's back in the start?
Another detail in the rules is there is when you define the contest. I think the original sample program did define contest or whatever the function is or method, but if you'll see examples of defined lap contest or whatever course, whatever the thing is. Just change it to a defined lap. And the way that works is it's going to require a single marker beyond the course. And when you say run, it'll go all the way around the course and it'll stop, or it'll log the lap time at the marker. So if you do have stop logic, you probably want to disable it or end for now if you have some finish line detection.
But for the challenge course, how is the timing gonna work? How do we know when the robot's completed the course?
Oh, when you make it around and it hits the marker,
okay,
it'll log the time, and it does. I forget. Oh, I think.
But how close does it have to be to the marker?
What it does is it starts driving closer, and at some point when it's fairly close, it looks for a minimum. So, and I think it misses it, by 1 delta time increment. But I wasn't allowed to make changes. So technically what happens is it gets closer and closer to that marker. And then at some point it starts departing the marker. Stuff I learned a long time ago, probably from David Anderson. Anyway, so in other words, it's getting better, better, better. And then the first time it gets worse, 1 presumably tiny time increment, it'll stop. So
got it.
Technically, it won't be at the minimum, but everybody's treated the same. It's close, and it's certainly better than you can do if you're sitting there. Well, unless you're single stepping, it's probably better than you can do if you were watching your robot and jumping on the space bar or whatever to end the contest.
Okay, makes sense. So now let me just share my share. Oh, entire screen. Which one? That one. So you should see a screenshot, and I'm not showing the timing, of course, right? Let's let that be a surprise. I don't want to spoil the surprise here. Now,
you blanked it out.
In terms of progress since last time, so I'm making it through those S curves now.
Wow.
Okay, all right. So I'm making it through there now, and it's, obviously not right on the line there, but I think this is quite acceptable. I would hope. Now I'm not yet, doing the gate, so that's work that's still pending, but that hopefully shouldn't be too bad. Now, the thing with the S curves, it's still not very robust, and I don't know why. I mean, it's supposed to behave the same way every time, right? But it's just like every once in a while, it doesn't make it, right? It's just doing a weird thing, especially in D2, actually in F3, up there in F3. Maybe 1 out of 10 times it's getting off track, and I don't really know why I'm getting differences here, right? It's supposed to behave the same way every time.
Well, either you're an idiot or I'm an idiot, and it's probably going to lean more toward me. The idea was really we should be dealing with a deterministic simulator at this point, but I think there's some little gremlins And I see the same thing. Yeah, especially, if you time warp it and put it in loop mode, you'll see it. And I thought it was the state logic in my own robot, but I'm starting to think there is something in LFS, and I haven't tried to nail it down.
I've noticed something that I think it has to do with how the discrete event time in the simulator overlays with real time in the computer run. Because I've noticed, because I was trying to do a PID loop tuning on one of my PID loops. I had to get the word out. It has been like a whole hour we haven't used that word yet. So I was working on that, and in the process, I noticed that I would get a different step response if I did it in full speed mode versus if I did it in like 6 or 7 or 8 mode in terms of speed. So there's some kind of mapping in there.
Hey, yeah. See if you can find that bug. It's all there.
Yeah. That's okay. That's why my one lesson out of the week, out of all this, is that slow speed might be good for figuring out the overall structure and logic, but with this ridiculous gauntlet that this one Chris Netter has put down, whatever that gauntlet is, because he's hiding it in the spirit of competition, whatever that gauntlet is, I mean, the only way to go here is to just go balls to the wall on full speed and just make the damn thing work.
Well, you can study his cookies, cookie crumbs, and you can see we could probably figure out how fast he's traveling, assuming he's probably doing max acceleration and deceleration and turns.
Well, he's hitting the gate at 10, so.
Oh yeah, there you go. He is giving away some. That's true. We know what.
Yeah, that's actually quite slow. I'm surprised. Oh yeah, you know why it's hitting the gate at 10? Because I'm going into a turn, and anytime there's a turn, I slow down a little bit. So
you just tap the brakes lightly, don't you?
Yeah. So the bottom line is, I guess I got to add a little bit of robustness. Works 9 out of 10 times is not yet good enough. Then.
Yeah. The one thing that I was suspicious of, but really in a run, it shouldn't make any difference. One concern I have about the program is how any sort of key press responses, because those may be handled sort of asynchronously. And that's something I really need to nail down in processing. But ideally, this thing was supposed to be deterministic at this level. The idea being, you have a deterministic simulator, and then later we could say, okay, the simulator's not going to drive your robot quite straight, and it's going to be some random function, that sort of stuff. But this go around, and for development purposes, it's one of those luxuries you have with a simulator. You can make it run perfectly, or you could start introducing slop or whatever you want to call it, different types of errors. But anyway, and to answer Ray's question, now the cookie crumb density here, we can't really tell his velocity because the cookie crumbs are dropped with a distance threshold and not a velocity threshold. So, which would be a nice feature, would be to have cookie crumbs that are placed, at a uniform time spacing. Then we would know what Chris was doing. But anyway, if you study the radius, his curves, interesting. Yeah. Anyway, and sorry about that. Yeah, the problem with glitches in the runs. How many runs are we given, Doug? Is it 3? 2. 2. Okay. Anyway, boy, that sucks. 2
Yeah.
is bad. Yeah. I guess that I'll give that some thought, and if I can track down something, technically, I guess the library code is nailed down, but there might be a workaround, in the regular code. And if there's a bug and it can be worked around, I think that's fair if it's given to everyone here. But
level playing field. We all got the same thing, right?
Yeah. Okay.
Level playing field.
Yeah. I think I gotta change my S-curve following logic a little bit. I think it has to do with the fact that, again, I'm kind of on the line, off the line, back on the line, right? with the offsets there, and probably hitting some corner cases. And then, that's why occasionally it just doesn't work right. So I've been experimenting with making my line sensors, thicker, right? So each pixel, each dot sees a bigger area, so but that didn't really seem to help me much. But I guess I still got some room for improvement there. And then, and then the gate, and then I'm done. And then, you better, do you have a slow motion mode here? Because I think the time warp, it's just, I need the opposite. I think you're going to have to put a slow motion in here. Otherwise, you're just not going to see it.
In contest run, you get in contest run, of course, but Carl is saying he doesn't trust it. But of course, in contest run, you are allowed to slow it down a bit. You're just
I forgot, right? There is slow motion.
I think at normal 1x, even your lousy 10 inches a second around those turns will be bored to death.
So almost there.
Very good. Wow.
Oh my goodness.
Well, you're there. Yeah. So you just have to write a little pattern recognizer for that end gate, and you're done.
And I think that 9 times out of 10, that curly Q, that's a feature. That's pretty cool.
Yeah, that's cool.
I mean, however you managed to do the loop and actually get back on the line, that's impressive.
I have no idea what happened there.
I think that David would call that a pirouette, I think.
Yeah.
S-curve pirouette. Yeah.
That was probably 12 inches a second, that curve right there. So.
Yeah.
Actually, that would not disqualify you. So
yeah,
if you recaptured the line, you were still
you're good.
Yeah.
All right.
And you figure the G-forces on the robot at that point, stuff would be flying off of it.
Yeah. But in F3, what happens occasionally, it just goes way off and it doesn't come back. So again, I gotta probably slow it down more in those S curves or tweak something. But here's what I found: when I slow it down too much, sometimes it makes it worse.
Yeah.
Because, right, I kind of just keeping going helps sometimes filter out effectively those transient, glitches that you pick up with the sensors when in between lines. So if I can't go arbitrarily slow with the way my logic works, because then it's just even more likely to go out of whack, because some of my logic is actually quite simple. And one way I'm approaching some of this now, I found is, I'm using the same strategy most of the time. For the gap, I'm doing sort of a canned maneuver here, but for the S curves, what I found is easier to do is, okay, I just decide, all right, I think I reached that place, so now let me use my standard logic, but let me use different parameters, right? Mm-hmm. Obviously speed, right? But also my coefficients that determine how the error factors into the turn rate. I just temporarily use different parameters, right? And then decide, okay, I think it's now time to go back and just use the standard parameters, full speed and whatnot, right? And so it's simple, but maybe it's too simple to make those S curves reliably. But that's what I'm doing.
Looks good.
Hey Ron, when you say in hyper mode or super fast mode, do you reset, like the position of the robot and start exactly in the same place each time, and you zero out, say encoder counts and any other state variables that?
Well, that's the goal. Yeah, and I mean, what's going on there is a good question. But
well,
I
found that I wasn't resetting my own state logic, and that tripped me up quite some time, right? When I started using that stop and go feature and figured out the marker, it was not doing the same thing every time until I realized everything that I stored in some global variable or some state information, basically, I had to, well, basically remember, hey, I got to actually reinitialize all those things
Right.
in the user init function, which I wasn't doing previously that way. Otherwise, I can't use that stop and go feature.
Well, the one that should work, that shouldn't matter, is the if you go to marker, because technically all that does is it executes a freeze, and what that means is, and then some care needs to be looked at there. But hopefully the goal is that when it encounters that marker, what it should do is it should no longer, well, call your update, and it shouldn't update the position of the robot. So it shouldn't be allowing you to give commands, and it should not be advancing the position of the robot, calling the simulator's motion update. But somewhere in there, maybe there's a hiccup, and that should be findable. And maybe I now have a robot. I'd like to improve its speed, but maybe I should just really spend my time seeing if I can find out why this program has some slight anomalies.
No. Ron, you got to do your robot. You've got the same level playing field we do, right?
Yeah.
Do your robot.
One kind of cool thing, just kind of a little bit off the subject, but not too far, is I didn't let's see how to say this. I can get my words out here. I found Carl did a abbreviated version of the contest course, and in fact, I don't know how that came to be, but I think then I took his abbreviated version, your abbreviated version, Carl, and I had that printed as a banner. And that's pretty cool, because what I did, I'll just show you what it is. Of course, you'll know it, Carl, but let's see, just for everyone's benefit, I'll bring this up.
It's probably one of the ones that fits in my foyer.
Okay. Yeah, so here's the abbreviated Carl. And the cool thing, what I did with this,
you got to share it on. It's not.
Oh, it's not shared. Okay, yeah, there we go. And there we go. Anyway, what I like about this course is it really has a lot of the features of the challenge course. We have basically, I think it might lack a 270 turn or something, but it's got the good stuff, I think. And anyway, it was interesting that I was able to quickly just change one parameter. I think it was a PID parameter, to get this one to run versus the challenge course. So, I mean, because this does have features in different places, although some of the major stuff is the same features in the same order. But anyway, I was kind of pleased to see that that this course, and I really like this course. And what I like about it is really, if you leave off the numbers, you can save about, well, put it this way, in the thought of creating a real course, and I'd like to promote this one, because this one is more compact. Maybe when we still want to try to solve the main challenge course. But what I liked about this is it's compact, and if I strip off the coordinates, and I went ahead and shrunk it by 2% when I sent it to the banner company. So in other words, my tiles are actually 11 7/8 square. But what it allows me to do is create this course in a 6x8 grid. So that's basically 48 square feet times $1.75, whatever that is, 60 some odd bucks or something, or 80, whatever it is. Maybe it's 80 bucks. Gee, anybody with a good calculating skill, is that right? So, well, whatever, 48 times $1.75. So I guess it's, what, 50 times about 75 bucks. Anyway, this is kind of cool because also it's compact, but it doesn't cost 140 or whatever the big contest course costs. And so I do have this for my real robot. So my plan is I'm going to use both the simulated, this version, and the real one to work on my real robot. So anyway, and originally I was going to get a contest course printed, but gee whiz, 150 bucks or whatever it is. Okay, that's my story.
If you want to go really cheap, which is what I did, there's a series of individual test courses, test course 0 through test course 3, and each one's takes particular elements. They're not all combined, but it takes different elements. And I think the most expensive one is $20. So, I mean, that's I can see why you, Ron, would want to go for the compact course. That's, that'd be great. But I'm just saying, if somebody just wanted, for example, to test stains, they could use the one that has stains, and I think it has a little acute angle on it, and it's small. I tried to make the first couple of them 3x3, and the reason I did that was that fits in a lot of places.
Right.
So, but what is it? So that's 9 times $1.75. So whatever that is, it's less than $20. So, but that's an alternative. They're all up on the GitHub, and they might even be. Well, I put them in one version of the data files. In the data directory of one of the ones we did. I don't know if on the GitHub. I don't know if they're but you can just take the GitHub versions and make them at 64 bits per inch, and then it works.
Well, I used the somebody wrote a program that generates the courses. So this took like 5 minutes to generate using the course generator. And I'm giving some thought to that. I think it would be pretty easy to make a course with several tiles that could be at runtime altered, without any difficulty. It might take a little bit of thought to come up with an algorithm to generate a complete course. But if you're willing to just have, about a half a dozen different areas where you could specify what can go there, then it wouldn't be too tough to make a real time, press a button and a course appears, a sort of random course.
Well, the thought was before COVID was that, we would, every year or two, we would make a new course, and then we would have a collection of courses that you could use. And it wouldn't be a big hardship on the club's dues either. So, but we have talked about just maybe for the gate area, instead of buying a whole new course, we just put a new gate on it.
Sure.
Stuff like that.
Sure.
Doug, did you want to go next? You got something to talk about from this week?
Not too much. I've been very busy. I've been trying to hunt down some. I took a hunting trip. I think I remember telling you guys about that. Well, on the way down there, I got rear-ended, and then a little further down the road, a big rock from a truck hit my windshield. So that essentially is going to cost me a couple of K. And my car has 2,000 miles after the trip. When they happened, it had probably 1,500. So, and getting that all taken care of. But I did want to say to John, if is he still here? I don't see him on my screen.
John Case here. Yeah.
Yeah, he's there.
Yeah, okay. Not John, our friend in
the other John.
Yeah, the other John. The one in California.
I don't think he's online today.
Gene Shu.
My son is playing piano again. I'll go on mute.
Okay. Well, anyway, I was looking around and I found this in our DPRG clips, and it just might be. I'm going to push the thing. So this is I think 2018, and it's all 3 courses, and it was people running different stuff. There was a lot of it was I believe it was in November, so it was a lot of experimentation going on. But if you want to see real robots running around, that's a good video to see. Okay. That's our I think it was the November competition.
Nice.
So let's see.
For some reason, I'm not seeing it.
It's a link in the chat.
Yeah, thanks, Doug. Oh, yeah, I have had a question. How far is the rule of thumb for deviating from the course, like the allowed distance? I was gonna use 1 inch, but just
Well, those lessons are coming in handy.
So allow deviation from the line.
Look at those runs. Look at the one that I highlighted. That's my robot. Look at that, and you can see what you would expect to really run a robot, and you should be at least that good or better.
okay. All right. Good guidance. Thanks.
John, that sounds quite exciting there. And there's I think the Gong Show guy. So, Mr. Anderson, did you have something? Did you have a gong performance?
Isn't that John?
He's still David.
Oh, no,
Dave Anderson, your audio is not working, which is a real shame given the instrument you have there in the. Try the mallet on the screen. That might help.
Would it help if if a bunch of us muted? Should I shut up? I do have a question to ask David, but I'll shut up first.
No audio, David. I don't know.
I don't have any motion on him either. Is he moving?
David Anderson is moving all around, and there's significantly disrupted gestures. And now we're doing the Macarena, and his iPhone isn't working, and I don't know what's going on.
Let's do charades.
Looking for the phone number?
Maybe you can't.
Oh, this is good. Okay. All right. Carl, so do I have audio? I don't know if you have audio, but we do not have your audio.
Oh, is he messaging?
He held up a sign that says, Carl, do I have audio? David, I don't know what's going on because you've got the 518 number dialed in by phone, right? Or is that somebody else? 518 is on mute. No.
Use the chat, David. Use the chat.
But the charades are more fun.
It's like that guy on the Star Trek episode. Maybe he could just beep once or twice and we'll interpret. Who was
Commander
that?
Pike. Yeah.
Yeah.
So David, there's nothing that we can do to unmute your audio. No, we cannot hear you, David. We cannot. You have the 3 green dots, which indicates that your computer's unmuted, but it looks like maybe the hardware microphone is disabled on your computer or something like that. Or your phone is turned off right now because your ear. I'm sorry, David. We're just stuck tonight. Maybe can you dial in by landline using that trick? It says, but he's. Oh boy. This is like the airplane movie. I don't speak jive. Okay, that was a reference that a few people got.
So would it help if a bunch of us muted? Would it decrease the bandwidth?
I don't think that's the problem. I think it's between whatever microphone David has and Google Meet. Oh, now he's going to come out and come back in.
I picked a really bad day to stop sniffing glue.
That was awesome. Okay.
Hey guys, look at that video. The real robot checks well. It's crazy.
Yes, the gauntlet is down there, John.
Yeah. All right. I'll put it like ½ inch.
Put that to your guide. But realize that might have been kind of slow compared to these simulator runs. So.
Oh yeah.
if we arbitrarily decide that a ½ inch is the right limit, then it might kick Chris out of the running right away. You might have to slow down to 0.9 the speed of light. I don't know.
Chris's crumbs look great. I don't see any issue with them. You know,
They look great.
Good. I'm
they
glad.
look great. You know, I mean, I think, you know, his 90-degree curves are a little soft, but you know.
Okay, David Anderson,
He's probably going too fast.
Okay, David Anderson, you're back. Can we hear you?
He's muted.
Now your meat is muted.
Carl, before we forget, can you make sure that you do a screen scrape off of the, you know, just do a select all on the chat, and so we don't.
Oh yeah. No, I get it every time. I just forget to mail it to you sometimes.
Okay.
Okay, Dave. No, speak, David. Huh? David? Nothing. It's no luck. See, we had a problem earlier with Daryl Coates' audio too. I don't know if your audio is working, Daryl. You're unmuted at the moment, but
I'm on the 518.
You're the 518. The 518 is working. Dial in. Okay. Somehow it's working from wherever you are, but not from SMU area. Well, if we bounce over, so Daryl, you've been very patient the whole time here for our club. Welcome aboard. I think this might be your first time or so here. So hopefully it's been interesting enough for you.
Oh, yes.
Cool. Is there by the way, any kind of robot project you're working on? Anything you'd like to share?
Yes. Well, I got into robotics about a year ago.
Now?
And I started Ross at that time. And it's been a challenge all the way. But I've purchased an MIT racer. And then I deviated from that a little bit. I bought a NVIDIA TX2 with a RealSense D455 depth camera.
Yeah.
And so what I'm working on now is getting that all working together.
Mm-hmm. That's great.
So I feel like I'm on a scale to 1 to 10. I'm at about a 1.5.
Well, you picked a really challenging project. So I mean, most of us crawl a little more before we go into those type of hardware. But you know, hey, if you're at a 1.5 on that hardware, you're doing great.
Well, I haven't had all of the hardware. But I've just received the real depth sensor a week ago.
Okay.
And right now I'm building the chassis and everything for a 1/10 RC racer.
Okay. What do you know, what model did you pick just for grins? I'm curious.
I got the Tamiya. I think it's a TT2.
Okay. That's okay. Yeah, I went with a Vandal, a Quantum Vandal, and replaced the motor and everything to do that, to try to get the speed down to a reasonable rate. Because I didn't really want to go that fast. I wanted the robot to roboty cross. So, and I was also using an autopilot to do most of my navigation for me, and just using the controller to handle what I wanted to do with the autopilot. But I still hadn't got it to the point where I can stop on a cone. So that's what I'm trying to do.
I see.
Yeah. So we have a contest. It's kind of like a bar that we try try to go up against. And essentially, what you do is you have 3 cones. They're set about 100 yards apart, kind of in a big triangle. And the shot from the first cone, or the home cone where you start, the first cone is not, there's nothing in the way. You can just put your robot down, point it in the right direction, and in theory you could go to the other cone. But the cone from that first cone to the second cone, and from that second cone back to your start position, there will be objects in the way that you have to go around. Now, you can do that either by just doing waypoints. That's the beginner way, where you can do it the way David and Scott, one of our other club members, Scott Gibson, do it, where they go in a straight line, and when they hit something, and they don't hit it, but they see something, they move around it. So that's the more advanced way of doing it, but like I say, the beginning way is you drive up to it, you do a curve, and then you just make waypoints around the obstacle. But in real life, that's not always, that doesn't always happen. Sometimes you hit trees. That's not
right.
Because when you, especially if you're using a 1/10 RC racer, man, when they hit a tree, they hit a tree. There's none
They
of this.
explode.
It's like, yeah, I would recommend trying to slow it down if you can. You can do that by getting higher turn motors. Probably also, most likely you don't have what they call sense on your motor, so you don't have any real speed control. It's all open loop. If you do, if you can get a motor with sense, that'll help that. It's essentially it's got 3 what do you call them? Magnet sensors. I can't. What are they called?
Hall effect?
Yeah, Hall effect. 3 Hall effects in it. Or they're picking off the Hall effects that are already in the motor, and they're essentially rotating, giving you access to that signal. Well, not you, the motor controller. They're giving the motor controller that access. So like if you tell the motor controller, I want it to go 100, it will go 100. If you tell it to go 200, it'll go 200. And the nice thing about that is if you get a slick spot and you bog down, your motor will try to correct it a little bit. But
yes, I purchased a VESC 4.12, I believe, and that should give me all the parameters.
Yeah. So we would enjoy watching you make progress, and we just show up every other week or so, or every week if you really want to, and tell us how you're coming along. And we will
do.
Sometimes we can kibitz and answer for you. We got some people with a lot of talent, and I'm looking at some from Outdoor Rovers. Probably the one here is David. He's been running Outdoor Rovers for 10 or 15 years, right, David? Long time. Yeah. That's why he's got a gray beard.
And we are planning an outdoor contest, hopefully in June, July, COVID permitting. So, Daryl, what part of the country are you calling from?
New York. Oh, okay.
Okay, that might be a bit of a haul.
That might be a haul. That might be a haul.
But we did have somebody fly in from Vancouver to Dallas for an indoor competition one year, so
we did.
We would be happy to host you.
Yeah. But if you're interested, there is a rule set on the DPRG website for what we call Robo Columbus. Okay, and then there's obviously the Society. Is it Seattle Society of Robots, which runs no, that's not it. Yeah, it's something like that. And they run out of Seattle, and they're the actual originators of the Robo Magellan contest, which is run by several competitions across the United States.
Okay.
Although Donna tells us that they're a shadow of their former self.
Yeah. Well, everything waxes and wanes, but they do still hold a big competition with lots and lots of competitors. We would really be odd to have that many competitors. But
Darryl, we put some links to our rules if you find them helpful from our website in the chat. So
yeah,
it's all public domain. You're welcome to do it as you need.
Yeah,
great. Well, thank you very much for the warm welcome.
Cool. Yeah, you're welcome. Thanks for joining. Yeah. All right. So let's move around. I think there's still maybe 2 of us left or 3, but Mr. Anderson, your audio is working now.
Do I have audio now?
Yeah. Oh, that's awesome. Can you have that on contest day? So if somebody gives a sour note, you can just gong them?
That's right.
Oh, well, absolutely.
Excellent.
I was making notes here while my audio was dead. So I'd just like to go over this real quick, and then I have a brief report. So number 1 note is I've just been overwhelmed at work, running down some problems in a big complex system, and it made me think that I don't know if the group is appropriately appreciative of what Ron Grant has given to us, which is if we were to have bought this simulator, this is a $50,000 piece of software, and his support and his willingness to go in and hack on and change things, which cost me $300 an hour. And so I want to put in a hooray for Ron for putting in all this time and effort at such a professional level. Absolutely.
There's your price tag, Ron. 2 of them.
Thank you.
Hourly rate and the package rate. You got a benchmark there.
Okay. Second thing is, and I don't know if this for sure applies to what Chris was talking about, but my experience with robots is that the kind of robots we build behave according to chaotic rules. That is to say, they're incredibly sensitive to initial conditions. And so if you run the same course 3 times, each time you go by the starting point, your heading is slightly different, your position is slightly different, your momentum is different. And so each run is different. As I say, that may not apply to this particular problem, but I know in the real world it's very difficult to get a robot to do the same course multiple times and follow the same pattern each time. Because, as I say, of the deep dependency on initial conditions, which change each time around. So if that's what this is doing, bravo.
Well, my goal would be to have the control to say, okay, for your development, have a nice clean playpen, and then introduce the randomness or introduce the things that make the robot mimic the things we typically see. And one of those is the inability to place the robot exactly, or have it run exactly straight, or perhaps slip when you try to push the thing to a high G acceleration around a corner, that sort of thing.
Yep. And just the oscillations, the slight oscillations of driving in a straight line means that sometimes you approach a new object from this angle and sometimes from this angle, and therefore the behavior is different. And let's say that's a real world phenomena as far as I've been able to determine. Okay, that's all of that. Because I've been so hosed at work, I haven't done any robotics for months now. but I've been reading a lot. And I sent a note to Murray about this a few weeks ago. And so I want to describe my thought process. I was reading about ROS. I followed a bunch of blogs and I followed a bunch of builders. And one of the things I discovered is that it seems like what most of them are doing, or the ones I follow, is that they have a Pi that they're running ROS on, and then they have another processor that actually runs the robot. And that basically the Pi is not asked to do anything real time. And so I started thinking about that, and I started thinking, well, actually, that's basically the robots that I already have are the pieces that run underneath ROS. And so I started reading about what would be required to implement that. And everybody I read said, oh, you don't want to do ROS, you want to do ROS 2. So I started reading about ROS 2, and that led me to read about data distribution services and what's the standard object management sessions, which is basically what this is all underneath the ROS. They call it their intermediate or medium level. Basically what they're trying to do is that makes it not only hardware independent but language independent, so that you can define things like variables and arrays and even processes, functions, behaviors, the things you would see inside a normal object, data, and then functions to operate on those data that are defined in a very strict protocol. And then you actually have a compiler that turns that into the hardware instructions for a particular language. So if you're writing in Python or C++ or, good God, Fortran, that you have a common transport mechanism to communicate data between those two. So if you look at their flow chart, you have ROS sitting on top, then you have this intermediate level that does all that translation, and then the lower levels, which, as I say, are essentially the robots that I have now. So I went back and looked, and basically it looks like the way they're doing it is on the lower level, the actual robot, they run an RTOS. They seem to prefer free RTOS, which, if you guys have looked at it, is a spitting image of the RTOS that I use. There's only a few minor differences in syntax, and of course mine is better. But at any rate, on top of that, then they run something called micro ROS, which allows you to have a ROS node on the microcontroller that's actually talking to the hardware. So I read through micro ROS, and it looks like it would be a fairly straight-ahead port to my RTOS. And so I'm thinking about doing that. That way I don't have to change anything I'm doing now. The robot still behaves the way it does now, but then I could stick a Pi in on top of it. My goodness, here's one right here. To talk to the micro ROS interface. I don't know that I'm going to do this or not, but I've been reading about it a lot. And I will say that in some ways it has reinforced my initial impression, which is that if you ask a beginning robot builder, looking at you, Harold, that this is the way you're supposed to start, good God, I think they'd go into ice skating or something else. I think robots would just, it's an enormous amount to learn.
Yeah,
to try to drive a robot in a straight line, which is what most of us still struggle with.
Yeah.
However, I'm kind of fascinated by it, so I'm gonna. At this point, I'm just reading and making notes, and so that part's easy. So that's what I've been doing. I don't have anything else to offer. Ron said you had a question.
Oh yeah, when you were talking about your pirouette problem, I guess I wrote a quick simulation. I'm looking at it, and anyway, I've shown this before, but I'll go ahead and put it up just for fun. And I guess my question was, were you attempting to drive with a constant forward velocity while varying your turn rate, or were you trying the other way around, or what was the story there?
Well, it actually the forward velocity accelerates and decelerates, but the rate of pirouette remains constant. that's just the constant. I said I want to have a rotational velocity of 40. And so it sits there spinning around, and then in that spinning, I want to be able to steer the thing around. I actually thought I'd shoot a video of that and submit it for the contest.
Okay, because I guess I did the simulation. I'm kind of looking at the code, and it's now been a months. Let's see. October. So I don't even know what I wrote here, but I'll show it for fun. And so what I did is I simulate the entire run of the robot in a 1 frame time, so you can see it run for 5 minutes, or I guess 300 seconds, whatever that is, or 200 seconds, about 3 minutes. Let's see. Let me fire that up. So anyway, my goal was, and I can't remember, apparently I've got a couple parameters I'm varying, but you can see the robot drive. And so I'm driving with a constant
Ron, you got to share your screen. If you mean to share your screen.
Yeah, same thing. Here we go. Yep. And here we are. So here the robot is, and I can't remember. It looks like I have an initial. Still not sharing. Let's try it again.
There you go.
There we go. Okay. So I have, apparently I have an initial heading, and then I have, so what I'm doing to accomplish the trajectory is I'm driving with a constant forward speed, but what I do is I kind of cheat in order to come up with that trajectory. What I do is I elongate, as I'm coming around, approaching the heading, the desired heading, then I start to, I change the turn rate. So in other words, I cheat a little bit to create this pirouette, but drive in a straight line. Does that make sense? In other words, if we just let's see how to say this. So in other words, we have to vary.
Well, that's similar to what I'm doing, but I'm not varying the rotation rate.
You're varying the forward speed.
I have to back up a step. The robot itself is controlled by 2 values. One value is the rotational velocity, and the other one is the translational velocity. So when you normally drive the robot in a straight line, the translational velocity will be, some positive value, and the rotational velocity will be 0 when it's normally driving in a straight line.
Right.
If the translational velocity is 0 and the rotational velocity is some non-zero amount, then it'll spin around its center, staying in one place. Okay, so that's what I'm doing. The translational velocity is 0. The rotational velocity is a constant, so it's spinning around its center. Now I take the sign of the heading, and I use that to scale the translational velocity, so that it's adding through half of the turn, it's adding, and through the other half of the turn, it's subtracting, and that's driven by a sine wave. My original question was that I expected that sine wave to be 90 degrees out of phase with the direction I want to go, and it turns out it's 112 degrees out of phase with the direction I want to go, and that confused me. But I believe that what I'm seeing, that the reason for that extra, what is that, a quarter turn, has to do with the latencies in the actual behavior of the robot.
Okay.
Which I don't think you would see in your simulation. See, the difference is the way yours is doing it is asymmetrical. That is, you have little curlicues. The way it's here, the curlicues are always on the bottom. And the way I'm doing it is symmetrical. The curlicues swap side depending on whether the front is facing forward or the back is facing forward.
Oh, okay. Okay. Yeah, I guess my solution was as I elongate the, let's see how to say this. So this example is constant rotation rate. So this is rotating at a constant speed, but I guess what I do is I symmetrically, as the robot is spinning around, what I'm doing is I'm varying the velocity, but symmetrically about the desired heading. So in other words, but I think I'm doing it with an exponential function. Let's see. Yeah, it looks like it. So
where are you reading the heading, Ron? I don't see the heading.
Oh, the heading is being, let's see. So here we have the robot's heading and trajectory calculations. So here we have, let's see, a heading rate, and the heading rate is dependent on the wheel velocities and wheel separation. And so what I'm doing is I'm doing basically a first order integration of the change of the heading. So I'm calculating how much the heading changed in a time step, then adding that to the heading. So here's where you're seeing it there. So there's, yeah, okay.
Okay, so basically that line there, I'm pointing to my finger. You're basically doing a quick odometry calculation there to get the heading from the wheels.
Right.
Whereas I'm actually reading my heading from an IMU.
Okay. 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 So I need to simulate an IMU, is it? And all it's, yeah, so interesting. Well, interesting. But
well, cool. Cool,
anyway.
Ron. Thank you.
But yeah, that was kind of fun. And when I first started this, I did it in the normal sense where I updated one. In fact, maybe this is what led to the time warp for the line following simulator. Is by doing this, it got me into the habit of thinking, well, gee whiz, why do one update per drawing, per frame update, which is pretty fast, 60 frames a second. But yeah, so really, so what I do is per frame update in here, you can see, let's see, wait a minute. So in here, I have this thing I call time lapse. So really what I'm doing is I'm iterating 200 iterations, calling this update, which updates the robot position and the heading and everything, and the XY coordinates based on the heading and the speed and so forth. Anyway, so I guess that's what kind of got me the idea of, hey, why don't since I can make this do this 3-minute run in one frame, then that probably helped me come up with accelerate the time, the LFS. Okay, anyway, end of story. Okay, I'm shutting up. Sorry, talk too much.
Cool, Ron. Very cool.
Back to Ross for a second. So regarding your conclusion, David, that you can just use your existing robot and kind of add a pie to it. I mean, I think that's absolutely correct. I'm not sure you need to go as far as using micro ROS. I'm not yet up to speed on ROS 2 as much as I am on ROS 1, but I think if your goal is to take your existing robot and all the firmware that's on it and add a layer on top, you can probably just use whatever the equivalent is of ROS serial, in ROS 2 land, because micro ROS, as I understand it, it gives you, much more of a ROS compliant programming environment on your microcontroller. In other words, if you wanted to write a piece of logic that uses ROS APIs, you can run that on a microcontroller and it's using micro ROS, and then you can put it somewhere else and run it somewhere else. But that's maybe not what you're after, right? Because in the end, I think what you're probably after is you want to treat your existing robot with the existing firmware just as something that's publishing certain information, right? And it's going to be odometry, and it's going to be whatever sensors you have on it, right? And it needs to subscribe to certain information, and basically that's the command velocity topic in ROS. And to get an Arduino or a microcontroller talking to ROS and to achieve this sort of public subscribe between those two worlds, that's where ROS serial comes in, right? You run a full-blown ROS node on the Pi. It's the one that is actually publishing the odometry, but it's talking to the microcontroller over some serial protocol, which in this case is ROS serial, right? So you're not really running any kind of ROS software on the microcontroller. And that's how traditionally in ROS 1, at least, you bridge those two worlds together. Firmware running on a microcontroller and the Raspberry Pi over some serial link, or even over, other kinds of connections. But in the end, that's all you need, right? You just want the world of ROS to have visibility into your sensors, into your odometry. That's what your firmware does, right? It keeps track of odometry. And all you want, I think, really, is you want it to publish that information, right? And then you can have ROS nodes running on the Pi, subscribing to that odometry, and use it for whatever, and so they can subscribe to the sensors, and you're gonna have to figure out how you want to, in what format you want to publish your sensors that you have on it. But my main point really is micro RAWs may be overkill for what you probably trying to achieve.
Let me repeat that back to you, and let me see if I understand it. Building the micro ROS under the RTOS on the microcontroller, in this case, STM32 Nucleo, an ARM processor, in which I think I showed you before, I have like 99% of available processor cycles for free. So that would be a ROS node that would talk to nodes on the Pi. Your suggestion is that the nodes all run on the Pi, and that the ARM microprocessor be treated as a I lost you. The ARM microprocessor be treated basically as a peripheral to the Pi, and the nodes for it run on the Pi rather than on the microprocessor. Is that correct? Is that what you're saying?
That's correct. I mean, micro ROS, and again, I haven't done as much reading on ROS 2. Micro ROS is going to let you do a lot more than what you may want to do, right? It's going to let it gives you an actual ROS API and all kinds of layers of software, right, running on the microcontroller. So you're going to be able to do sophisticated things. You're going to have, if you see in this diagram, you're going to have application components running on your microcontroller, and those application components can use similar APIs that the ROS nodes on the Pi are using. But again, maybe that's not what you're after. If all you're after is getting the sensor data onto the Pi and getting the firmware on your microcontroller to receive velocity commands from the Pi, that's where ROS serial comes in. Harold could probably comment on a few more details how that works in ROS 2, but I think the keyword for you to look into and do some read up on is ROS serial. What does that give you? And maybe it gives you all you need for a lot less complexity.
Yeah, I've been reading all that stuff before you guys started talking about this, because I have to do something very like this, and I don't know what I'm doing, but I'm certainly going to try. See what, and Chris, I'm feeling the same way. There's lots of things there, but I do want to use with ROS 2, not ROS, not the original ROS, just for, I don't know, personal stubbornness, maybe that's what it is. You want to call it that? Yeah.
Well, Harold, I can say from what I've read that the intermediate level under ROS 2 talks to a data distribution service, the DDS service, which itself, if any of you are familiar with that, it is extremely complex. It's very powerful. It's like playing the cello. It's going to take you a few years before it doesn't sound like cats fighting. And I don't see a shortcut to get there. It looks like that the people who wrote ROS 2 tried real hard to hide the details of DTS underneath it. But there's an enormous amount going on there. It's its own complete data writer, publisher, subscriber, data reader, topic. It's its own complete system, and it's pretty, as I say, it's sophisticated, but it's extremely complex. I made a joke a few months ago, and I said it's like I'm going to teach you to play Chinese checkers, but first you have to learn Chinese. The tasks that you're attempting to do are not that complex, but the software as they've designed it to do those tasks is incredibly complex. So I think I might take that a step further, Chris, and say, actually, what I want is I want the Pi to act as a node to my microprocessor. I want it to have a camera hooked up. Yeah, I want it to have a camera hooked up to it and a TCP/IP stack. But the robot's plenty smart enough. You don't need to tell me what to do. Just tell me what your data is. Let me decide what to do.
Okay.
So I don't need it. Yes.
Dave, one thing that strikes me about this is that I don't know that many people in the world of, amateur robotics, but of all the people I can think of, it would seem to me you would be the last person who would need. I mean, it seems like part of the reason that ROS even exists is that people are not able to do what you are able to do, that they don't want to write the microcontroller stuff. And so they've come up with a very, very complex way of creating an abstraction so that they don't have to do what you're doing on your robots. And
well, I will just say, I will reiterate the comment I made earlier, which is at this point, I'm just reading and taking notes.
okay, and I'm looking at this MicroROS webpage, and this does remind me of a comment that I made, and we all made, I think, a while back, which was we all come into robotics for different purposes. And some people aren't interested in hardware and actually building robots. They're interested in robotics, and they're interested in software. And other people are very much interested in hardware and not so much software. And I look at this MicroROS page, and it kind of reminds me, I think, of something you said a long time ago, which is that I don't get the feeling these people are all that interested in actually running robots. They're more interested in the software. It's an incredibly interesting software package. And if you had some sensors and they were sitting on your desk, and you had an AI camera and all that, you could run some really cool stuff. But does it actually work on a functional robot somewhere? Possibly. But it's kind of a different world, and it's, like I said, not the world I think of you in for some reason. It's not like you're not capable. It doesn't seem like the kind of thing.
I will say that one of the things I've noted, and I've mentioned this before, is that when I follow these robot projects, I very rarely see somebody post, "Hey, let me show you a cool thing my robot can do."
Exactly.
That runs ROS. What I see is, let me show you how I got this data set to turn into this data set and be transported across this transport layer. And then everybody cheers and applauds. But I actually don't see much robotics. I don't see many robots. The few I have seen, they'll say, watch how I could drive forward, detect this obstacle, and drive around it. Something I could do with a 8-bit microcontroller 30 years ago. I admit that. However, I'm a little bit intrigued. Intrigued enough to, I want to have a more informed opinion about it and a little bit of experience. And I got this Raspberry Pi sitting here staring at me. I hooked it up and said hello and wrote a little bit of code, and then I put it back on the shelf. Because I think that the Raspberry itself, I believe, is not well suited as a robot controller in and of itself. So on that we differ.
Well, I will.
And I think you actually agree, because you actually offload all that stuff over your I2C bus to other pieces of hardware. You don't try to do real-time things on the ROS.
No, and
on the
but on the other hand, if you think about it, that many of the Arduinos out there are 16 megahertz 8-bit, or maybe 32-bit 8 megahertz. They're not running very fast, and they're not very capable in terms of processing power. They can do a lot with 16 megahertz processors. A typical Raspberry Pi is a 1.4 gigahertz 64-bit processor. So to say that it's not capable hardware-wise, no, I think that it is capable. I think it's just that people don't use them the same way. I mean, you're typically running Linux on them. I know that I'm not saying it's not a capable processor. I'm just saying the Raspberry Pi is equally capable from a hardware perspective. It can run very, very fast.
It's not the hardware, it's the Linux.
Mm-hmm.
Linux is not well suited for real time, in my experience.
No, that may be. I'm not contesting that. I think though that that the ability for a Raspberry Pi to go off and get a sensor reading and come back in very, very short order doesn't limit it as a robot controller. Obviously, because lots of people use them as robot controllers. And I won't defend myself, because we've had these back and forths a while. But but you're quite correct that what I'm doing is writing my OS in Python, which was my real goal, and then offloading all the sensor stuff over I2C to sensors that can do that. And I'm not having any real problem with that. My problem is that I've designed my own OS. But I do think that go ahead.
Another way of looking at that, if I can be so bold, is that you have a Raspberry Pi, and it's talking to a bunch of microprocessors to handle the real-time stuff, rather than just talking to one microprocessor to handle real-time stuff.
Mm. If I could program that thing in Python, I'd probably do it.
Oh, sure you can.
You can?
Listen, all computer languages are written in C. Fortran is written in C. Python is written in C. C++ is written in C. If you can run C, you can run anything else.
But is there a Python distribution for that?
Somebody with a
There
somebody Google that.
is. There
Well,
absolutely is.
for the Pi, you can run processing. That has a Python front end or whatever you call it.
Well, I'm running Python on a Raspberry Pi. The question is, can I run Python on what's the RTOS chip you've got, David?
Triple MicroPython for STM32.
Yes.
Yeah.
Number 3 in the Google search.
Python.
All right.
PyBoard.
Well, there's lots of little tiny boards that can run Python, but I'm just wondering if the one that David's talking about can. Because, I mean, again, my goal in all this was to learn Python. And I like Python. I'm really enjoying it as a Java programmer. I really like Python as a language. Maybe, other people's mileage may vary and all that, but I could go back to programming on an Arduino or something like that, but I have a couple Arduinos and I've played with them and I find it kind of not interesting to me for some reason.
I'm certainly not advocating for Arduino.
Okay.
Arduino was cool 10 years ago. It's way underpowered now. On the other hand, we use them at work. If all you got to do is read a couple of switches and send out some kind of signal, it's hard to beat.
Well, if you like
it's like 120 megahertz. That's pretty fast.
Yeah, there you go. Or the teensy. What is it? 400 megahertz or something like that.
Yep.
This is a 90 gigahertz part. 120 if you run the version I'm running. So,
you mean megahertz?
Say again?
Megahertz, not gigahertz.
This is
David's from the future.
0.9 gigahertz. Yeah. 120 gig. Thank you. And it's got, 512K of RAM and 256K of SRAM and it's 32-bit, but it's got what the Arduino doesn't have. It's got a big dog DMA controller and a nested vectored interrupt controller, which allows you to do all of that hardware stuff in the background. That's why I'm only using 1% of the processing cycles, because all the hard stuff is actually being handled by hardware.
Yeah.
So no, I'm not arguing. I'm not arguing for an Arduino. I think they're underpowered for what it is. I'm actually not arguing at all. Just throwing a few soft rolls to start a feed fight.
I have a question. I'm ignorant of Linux and most things actually, but with the Pi, which I dabble with that, I use it to do 20 to 30 frames a second video acquisition, and then I talk to a microcontroller to handle anything that's time critical. But is Linux, is that like a preemptory, however you say it? Is there a way to lock up can you take a hold of the processor? Or are you stuck with just?
No, you can take hold of the processor. You can put. I mean, if you assign your thread a real time, what's called the real time priority, and the maximum priority, it's basically nothing else. You can lock the whole thing up. Nothing else will run basically.
Okay, but I guess the other question is. That you might need is, besides locking it up, I guess you might need access on some basis that's fairly frequent. But I guess if you could lock it up, I'm just curious if you can get what you want out of it for running simple tasks that need to run frequently but don't need to suck the whole thing up.
Well, the normal Raspberry Pi has 4 CPUs, and so you can assign, let's say in Python or Java or any language, you can assign how many CPUs you use for a task, and like this little thing that I bought, which is the Fire 3, has 8 CPUs, and it's a Linux a little Linux project, and so it has instructions and everything.
Okay, so you could dedicate a processing core to that.
It's a NanoPi Fire 3, and I found out why it wasn't working. It turns out that the I2C bus 1 and 0 are swapped in the hardware on the pins. And when I got it, actually the guy that came back to me finally from NanoPi was quite helpful. And if I want my little where are those things? Pull one of these little breakout garden things from Tim Maroney. If I plug one in, they come up on the 0 bus rather than the 1 bus. And it turns out all I need to do is just wire these things to the 0 pins and it will actually work. So this thing is functional. And it runs hot at 65 degrees Celsius, but it's 8 CPUs. In any case, though, to answer you, Ron, that from the standpoint of being able to control the CPU, a Pi is fine. They're quite a capable little computer, and even the small, like the little Raspberry Pi Zero, is quite a capable small computer. You can do quite a lot with them.
Yeah. Well, it didn't do so good. Let it running processing. It sort of choked on that. But anyway.
Well, you're running a pretty big thing, but putting a small robot on it would be a problem.
Part of that also depends on how you define real time, which, you know, there's guys who write PhDs about that. But for example, at work, we run this international data system for all these big seismographic stations. And those are considered real time, and we run all that under Linux. So all the systems distributed all over the world talk to each other through Linux. But in that world, real time means a latency of no more than 10 seconds. So in the robot world, 10 seconds, you're already off the table and smashed into the ground.
Right,
you know?
right. Yeah, so what I'm saying is somewhere around 100 to 200 hertz, I'd like to be able to run my routine for, you know, X amount of time. But if I can have a CPU, and if I know that nothing else is messing with, let's say, the SPI port or whatever, then I should feel pretty good about that.
The problem with things like the Pi is in Linux in general is by default, it's the distribution you get, whether it's like Raspbian or whatever flavor of Ubuntu you can put on the Pi and the clones, they're not optimized for real time, right? They're optimized, you know, for smooth desktop experience, right? Because they always ship as if they were a desktop computer, right? They're not even shipping with what I would call embedded Linux. I mean, it's a desktop. It's configured to be a full-blown desktop, right? It's not optimized as a piece as an industrial controller. That being said, right? I mean, Linux per se is capable of, you know, fairly high performance, right? I mean, in that work, I often have philosophical debates with people. I mean, I'm kind of happy in both camps, but I've built a lot of Linux-based control systems successfully, and you know, again, if you configure it right, you can get a lot of real-time performance out of a lot of, you know, out of something like a Pi. It's still not going to come anywhere near what you can do with a microcontroller because there's just so many more layers involved that all your code has to jump through, so many more hoops to jump through. And the one thing that's always going to be there on something like a Pi is the jitter, right? Because of the cache, and again, because of all the layers of software, even if you optimize, if you configure Linux and apply the so-called real-time patches, if you do all you can do, you know, you're still always going to have a lot more jitter on something like a Pi than you'd have on a microcontroller, especially the kind that we use that doesn't have a cache, right? I mean, nowadays you get microcontrollers on steroids that have caches, but if you don't have a cache involved, there's no jitter, right? You just can't do any better than that. You know, down in the microsecond level of interrupt response, that's really, really, really hard, if not impossible, to achieve on a Pi. I mean, you have to start cheating. You know, people do things like using it's almost like a non-maskable interrupt kind of thing that's available on most ARM processors. It's called FIT, fast interrupt. It has like its own registers, right? You don't even have to sort of, you know, save stuff to, you know, it's on the ARM processor level optimized for fast interrupt response. So if you really need a microsecond level interrupt response, you kind of would have to do it outside of Linux, right? In that kind of way, you can do it, but it gets really hard. You have to really tweak a lot of options to get real-time performance out of it, and then you lose all the flexibility that you usually want out of the Pi, right? Because of the way we usually use it. But it's doable. It's just painful.
I will say one thing is that you don't have to use any of the distributions like Raspbian. In fact, Raspbian's been replaced by an Ubuntu subset now. But you can use OpenWRT and a whole bunch of other Linux distributions for the Raspberry Pi. And for like this little Fire 3 that I bought, it runs OpenWRT and a couple others. I can't remember all the list, but there's about 6 or 7 different Linux distributions. But I will say that you're correct, Chris, certainly on one thing, and that is that when you're running, for example, Python inside of a Raspberry Pi, your clock is not guaranteed to be more accurate than, I can't remember, it's something sounds horrible. It's like 10 milliseconds. In reality, it tends to be very accurate, but you're not guaranteed more accuracy running Python on a Pi than a certain fairly low resolution accuracy. Whereas on an actual, machine that's designed for microsecond accuracy on its clock, yeah, you've got that difference. I don't notice it actually, because the thing that I think I like about these sort of robots that we've been building is that they run on a 20 millisecond clock. So as long as that's accurate, you're fine. And it's certainly accurate at a 20 millisecond. It might be off by microseconds on the 20 millisecond clock. And so I don't really notice that problem so much because I'm not doing anything. It doesn't rely on the kind of accuracy for GPS and things like that. You're not down to the microseconds required on most robots.
And that may be, and Chris, correct me if I'm misinterpreting you, but when you need that kind of accuracy, for example, if you're running sonar, where you're measuring a distance, my sonar is measured distance to a tenth of an inch, which means that they have to be accurate to about 200 kilohertz.
Would you have a timer event for that? I mean, there you'd be relying on an event timer.
Yeah, basically. Yeah, there's a free running clock that gets sampled when the interrupt hits, when the echo returns. Does that make sense?
Okay, so are you relying on a dedicated timer? What do you call that? Pulse capture? I forget the term, but you know what I mean?
Yeah, that sort of thing, yeah.
Okay.
And that's the sort of thing that's not there on the Pi, right? You don't have hardware time capture on the processor. And so you have to do it on an interrupt. And by the time you get through all the layers, so for ultrasonic sensors, you kind of lose a little bit of accuracy there. Versus on a microcontroller, even if you do it in software, with interrupts, which I had to do on my Polar Loop controller, you lose 2-3 microseconds. It's not too bad. But on the Pi, you're gonna lose a lot more microseconds than that in accuracy. And so trying to do ultrasonic on the Pi is a bit of a challenge.
Well, that's a pretty good argument for your $3 microcontroller, other than it's cool to be able to do it locally with the Pi. But I guess if you're careful and you have enough flexibility with your interface to your microcontroller, then it, where you can turn the knobs or whatever you need to do without having to go back to the microcontroller and, change some code and compile it, then I think life should be pretty good. It's been a while since I've really worked on that very much, but it seems like that's the type of thing that I work for when I'm communicating via serial port from the Pi to a microcontroller. I try to have the knobs built in and things, so I don't have to go constantly back to the robot and recompile the code.
Well, that's one of the things we talked about, that it more than doubles the problem when you have to have 2 complete development environments. One for the microprocessor, one for the Pi. and then you have to spend some time thinking which side of the comm link does this particular problem get solved on, and so forth. In my microcontroller code, I tend to use a lot. This is historical. I tend to use a lot of global variables that any process can read. So the communication time between processes is, one microprocessor read. What is that? 3 microseconds or something. There's no translating it into a packet, sending the packet over a comm link, pulling it out on the other end, unpacking it, translating it into whatever data format you need, and then handing it to the process. So it took me a while to convince myself to add that extra step. But when I figured out that I actually can stick a ROS Pi on top of my robot without having to do any of that, that's the first time I got interested.
It opens some doors for you.
But what do you want the ROS Pi to do to your robot?
I want it to handle a camera, and I want it to handle a TCP/IP stack. Those are 2 pieces that I can't do on my microcontroller, or that I haven't done, I should say.
And then you're going to do computer vision like OpenCV on the Pi and just send the output to your microcontroller or some decision, or use it basically as a sensor?
Yeah, Chris, that's what I'm thinking tonight. Who knows how that might change.
Basically that would be similar to a Pixie or an OpenMV, right? Which is like a turnkey package. It does some object detection, color detection, and whatnot, right? And then it gives you outputs, and then you use that, right? So it's almost like sounds like that's what you might end up doing with the Pi. You build like an OpenMV setup from scratch.
Maybe so. I'm also thinking that that would allow implementation of some neural net recognition software, and which I could train up separately and at least explore those things.
Right.
But as I say, the idea that a beginning robot builder would have to do that in order to get his robot to drive 10 feet in a straight line just seems like it's expecting a lot out of the human race.
And we're not doing so well lately. I've been trying to dig around to find timing accuracy on a Raspberry Pi. I can't find any web pages about it. I had seen something about it, but I can't find anything. Maybe I'll post it to the mailing list if I can.
And I'm just disappointed because we've talked about David at work, you have 10-second latency and jitter. And then the Raspberry Pi, who knows what it is because it's undefined. It could be anything. Then there's microcontrollers. But what happens when the microcontroller jitter is too wide? I haven't heard anybody yet mention the phrase FPGA. I want to hear, I had so much fun with FPGAs in the late 80s and early 90s, making them run at the absolute clock rate limit spec'd on the part. It was great fun. But now there's just no damn need. There's no excuse to do it.
Carl, I have seen little Linux boards that have on board an FPGA that you can then program hardware to do whatever it is you need to do, and all of those latency problems go to zero.
They do. It's great fun. And the Hackster, you can find there's always a new manufacturer having a project on a Hackster where you just throw out some stupid idea and say, I want to try this idea. They'll give you the hardware to play with. All you got to do is code your stuff to an FPGA.
Okay, anybody here actually written FPGA code? Because I looked at it and it looks like cartoon characters cursing.
No. I did it in VHDL in the early 1990s, and
you're talking about the last century, right?
1990s, and but I had them running at the maximum clock rate, and then we compile to the same pinout no matter what I did to the code, so it can be done. Yeah. But like you say, it's another development environment, right? So if you don't want to mess with Pi and microcontroller, I think the last thing you want to do is add an FPGA workflow on top of that.
application dependent.
Very much
but,
so.
Yeah, normally the controller, I mean, these instruments, there's FPGA, and then there's DSP, and user software is on the PC.
Well, I mean, these
It
days you can
requires
take
a
the
team.
DSP core and compile it to your FPGA. So, I mean, it's just, okay, so you really want speed, go analog or quantum, but okay, let's not.
Well, also
Okay.
this takes us back to what our fiducials are. And I've had this experience, I'm sure other people in this club have too, sitting around a table in a planning meeting and realizing that, well, I'll give a specific example. For the vice president of engineering, what made good code was that it was tight and it ran fast and was small. For the vice president of software, what made good code was that it was easily portable to a different hardware architecture. So when they talk about, they use the same word, good code, they're talking about totally different things. And they look at each other askance, you know?
Yeah.
Good code.
How you define
Need
what's
common
desirable.
criteria.
Do you guys see the need of handling real time as well as having a UI?
Yes.
Yeah.
My
If
robot will
that's
have
the need, then you have to have two set of systems. Like one is the controller, the other is Pi or something else like a PC. Yeah, and then there's all the overhead. You have to get these two things communicating.
So always fun to synchronize two different asynchronous domains.
Well, John, actually, the thing that I found was that my first try at this was I wired up a little, since I already had a TCP stack and I could make a web server easily, my first thing was to make a little web page that I could control by clicking on and run my Raspberry Pi that way. I mean, and, you know, just basically receive those messages over a little RESTful server and do it kind of that way. And I just found it incredibly cumbersome. And that's sort of why I bought one of these guys, is that a little Bluetooth controller, ended up being my user interface. And I much prefer it because it's so immediate. And, you know, I've built user interfaces on, you know, web things and all sorts of stuff in Java. And it doesn't seem suitable. I mean, this is one of those things where
that's
I remember.
your UI, right?
What's
That
that?
little joystick is the UI.
That's the UI. Yeah, this is my UI. And I mean, I had a brief stint at NASA back in the 90s and actually got to pilot a little robotic sub under the Antarctic ice on a 1,100-foot cable. And it was a user interface on what was it? Not Solaris box, but what was those real fancy ones that were purple? Remember those? The Unix boxes?
That's SGI.
Yes, it was an SGI box.
Graphics.
Yeah, Silicon Graphics. We had a Silicon Graphics box in a demo for the public, and I helped set that up, and so they let me play with it a little bit. So I got to run the robot under the ice. And it has you clicked on buttons and stuff like that. And I still remember how incredibly cumbersome it was to kind of go left, right. Whereas, you know, if you got a joystick, it works really well. I much prefer a joystick. And so I kind of have a user interface of that style. And maybe I might have a web page that gives me status reports or something from the robot, but I don't want to control the robot that way. It's too difficult. I like having a button or a finger or something like that that can push a button.
Yeah, the little purple box was an IRIX, and that was my daily driver when I was working at Convex. And I had one of those things on my laptop, and it was really cool. You know, I even loaded up. I even loaded up. Go ahead.
Did you know Dwayne Gustavus at Convex?
I do know the name, and I probably ran into him a couple to 3 times.
I think he was head of the graphics group there at Convex for the last 2 or 3 years of their life.
I worked. The reason I had that SGI box was because due to the graphics, and I bet the name escapes me, but I bet I was part of the technical assistance center. So I was probably the liaison between those guys and all the testing they were having done. Yeah.
Well, he told me a great story about buying his little IRIX and running some test code on it and calling the vice president in and showing him that it would run faster nice little $20,000 computer than it would on the big iron they were selling for $250,000.
Yeah.
And the VP laughed and said, "Okay, what's the trick?" And Dwayne said, "There's no trick. These guys are going to eat our lunch." And they did.
And they did.
Yeah.
And they did. Yeah. Yeah, that was a really interesting time, and lots of really smart folks running around. I mean, we talk hardware and stuff now. Literally, when I was working for Convex, if I needed to go debug something, I could go get $1 million machine in testing and take that over for several days as I'm debugging whatever I needed to debug for a client. And we built all the hardware there. So we had the with the wave solder machines were there, and we had the anti-static stuff going on everywhere. It was really cool to go hang out with all that stuff and do all those things. It was really cool. And tons and tons and tons of smart people. I can't tell you how many smart people were congregated up there in Richardson, you know, in that the white, black, and gold building, you know, that we were at. It was really cool.
Well, this is way off topic, and we're probably wasting everybody's time here. But Harold Dwayne told me when he was hired at Convex, the last interview he did was with the president. And the president said, spoke with him a little, and then he asked, "Do you consider yourself lucky?" And the rumor was, after he was hired, was that he had never hired anyone who answered that question no.
That's kind of a Clint Eastwood quote, isn't it?
I thought it really. Are you feeling lucky? Well, I thought about it a little bit, and I thought, what kind of people would answer that question no? Well, one kind would say, "Oh, I'm not lucky. I've earned everything. I deserve everything." You want to spend 8 hours a day in an office with that guy? And the other possibility is they might say, no, everything I touch turns to shit. In which case you might well say,
"You don't want to do that."
"Thank you for your talking." Yeah.
Those are pretty interesting. Bob Pollack was the person that was running the whole place, and Steve Wallach was the VP of all that mess. And it was pretty flat orchestrated. Literally, if I wanted to talk, I didn't talk to them very much, but on occasion I would. But if I wanted to talk to them, their office was right down I'd just go knock on their door. I mean, there was a really open, really cool company in that, you know, small, even though they got to be about 1,000 people, it was a real small company kind of feel, like real startup kind of feel with all the folks. It was really cool. Really cool.
Okay, guys. Hey, before we break, one more update, at least that I know of. So I'm going to share, just because Chris is sinking, I think, in the screen. He's sinking lower and lower. And okay, there we go. So I managed to have a little bit of progress. I would only call it a little bit, though. So, and this was before Thanksgiving. So this was basically, I started the variant of SimpleBot, and this was in the contest line follower sim, right? And I adapted it to leverage the Mecanum wheels for hover sim there. And okay, it looks pretty clean. It has these funky things in the corners, but whatever. You know, this course, it was able to do that one reasonably well. Clearly, it can't hold up to the speed that Chris is running, but I get the gauntlet. The challenge is there. And clearly, though, with the SimpleBot line detector, it wasn't going to handle these other white on black contrast lines. So I had to do something. So I dramatically changed the sensors and the line detector logic, and I added special case detection. So I got a framework in place for that, and a handful of bells and whistles, and that's when all hell broke loose. Of course, all hell broke loose. So so this one still looks kind of clean, right? So at least, right, it can keep up with that one. This one, all right, it's doing this now, but to a point. And the S curves and the gate for me are going to be the last things I tackle, but because I've done it before on the physical robot, and I just get this guy working with Mecanum, but it doesn't like this course very well. You know, this course. Yeah.
Carl, with the Mecanum wheels, do you always face the same direction? Go sideways?
That's an option that I haven't implemented yet. So there are 2 modes to run the course that I plan to do with the Mecanum wheels. Only one of them I'll do for the December 12th contest. And the December 12th contest, like it'll follow this curve around. So forward is forward is forward. But then when it comes to a right angle, it'll just slide to the left. So my Mecanum robot, the orientation of front changes like all over the place. It's a very interesting thing.
Yeah, Will, if I might do a hybrid or a whatever you call it. It might be like a drone, because for Will, he had to know just how it was possible that the robot was able to turn and translate without any problem. So my final answer to him was it uses rocket thrusters. I've got he said you could do it with 6 rocket thrusters, but independently translating and rotating. And so he gave me his ID on that. So I said, okay, if I can do it, then he'll be a co-credited person. But anyway, it's sort of interesting, using all, both rotation, translation.
Oh yeah, no, it's pretty fun, and that's why my default skin uses rocket thrusters, of course, right?
Oh, okay. I'm sorry,
right?
I didn't realize. Okay,
but of all the features that I added, I mean, the most important is this magic button right over here, right? So Ron, I really want to thank you again to David's comment at the start, because I can click this, and I can click new skin. Oh, and now it's back.
Superfluous little features. Love it. This is what'll bring you down, Carl.
That's the only.
Yeah, that's cool.
Right, I got. Who needs to worry about the controller? I can just flip between skins. Okay. With the ta-da sound too, so that's it. So, okay, so I'll show the preview because I'm in stealth mode. But whoa, isn't that cool?
Oh.
And it's kind of slow, but these rocket thrusters work backwards.
Yeah, that's why Will pinned me down, and I said, okay, a pair or 2 pair to rotate it, and then forward, a pair for translate. Actually, 2 pairs: translate X, translate Y.
Yeah,
but actually, then you can do it with six thrusters.
Yeah.
Anyway.
Yeah. So I got a few things to work on, and then I really like that part of it where it crashes, Ron. That was really nice to add. So anyhow, that's all I have to share.
Very good, Carl. Looks like you're going to be there.
I'm going to be in the running, but it's going to be hard to be nipping at Chris's heels in the next 11 days. I don't know if he has a day job or not, but I do, and it's just
that's a killer. I don't know how anybody.
No, I do. You could pull a couple all-nighters. Come on.
Yeah. To the extent I'm a higher authority in the house allows me to do that, right? Yeah.
Yeah, right.
Well, at normal contests, the joke we always say is, well, it worked at home. So I guess what we're going to have to say here is, well, it worked on my computer.
I have a T-shirt that says that. That's right. It worked on my machine.
But it's going to be on
your... Yeah, but it is running on my computer.
Yeah.
This time it is. That's right. Yeah. No
then you can blame the screen share messing up stuff.
That's right. Oh, the time. What yesterday?
Time warp.
Speaking of time,
no, I'm looking forward to, once we get past this contest, I'm looking forward to people pulling back the kimono and seeing what we have under these different designs, because I think there's a lot of really different approaches I'm hearing. So
yeah,
I hate the analogy of pulling back the kimonos in this group.
Well, maybe that was a bad one at this time of night for this group, but okay.
We don't really know what anybody's wearing right now.
No, yeah.
Bunch of old men.
No, right. It's the wrong audience for pulling things like that back. Okay, and on that note.
I have one small update. I did a little research on the timing issues on Linux and all that. It turns out that Linux is not the issue here, that Linux has a general time accuracy in Python of about 1 millisecond. Windows is 16 milliseconds. The clock accuracy of a Raspberry Pi is way faster than that. So it's actually what you're running, which would be Python. So it looks like Python has about a 1 millisecond accuracy on a Linux box on a Raspberry Pi. Just to follow up on that.
Yeah.
But then on top of that, right, you have drivers that might take control of the CPU. I mean, that's what I saw when right?
No. If you use monotonic Python, there's a monotonic thing you get out of Python that gives you accurate to the clock of the Pi.
Really?
It's basically once you say monotonic time in Python, you're accurate to the clock of the machine, and the clock of the machine doesn't vary. It's on a crystal chip.
But does that mean you can you preempt other drivers and stuff?
Yeah, like how
No,
does,
you can't. You still can't.
garbage collection work in that situation?
You guys are talking about two different things. That there are going to be higher priority things running, such as drivers that are going to steal time away from Python.
Yeah, and what about garbage collection? And does Python rely on a lot of that?
Memory management, all that kind of stuff.
But I think what Murray is doing, if I understand correctly, is if he had to do something like our previous example of an ultrasonic sensor that requires, a 20 microsecond accuracy or something, that would be actually a peripheral that would do that kind of timing, and that he would just read back the results, which after all are going to come in every 30 milliseconds or something like that, over an I2C bus, so that that kind of precise timing is not required by the Pi. Is that right, Murray?
Well, there were two different things. Yes, that's correct. That in my robot, I don't require that level of accuracy because I've offloaded that. But from my understanding is that if you're running a thread in Python and you ask for Python monotonic time, it's actually tied then not to the thread, but to the system clock. And therefore, if you say, give me a 10 millisecond loop, it'll be accurate to 1 millisecond if you ask for monotonic time. If you don't, it'll be in the thread time. Is that correct, Chris?
I don't know about thread time in Python, but so I don't know how Python keeps track of time, but I think what you're talking about really has just to do with, what's the shortest delay you can ask Python to do, right? And what's the granularity of kind of the sleep function, so to speak, versus what Carl and I were saying is, well, there are going to be other things going on that computer that steal time away. So you're going to ask for a 10 millisecond sleep. And if nothing else is going on, you're going to wake up exactly after 10 milliseconds. But if something else is going on at the same time, and USB peripherals and Wi-Fi and whatnot, you might wake up after 20 milliseconds.
But we'll have to do a little investigation, clearly. But my understanding is that if you just do time sleep 10, you'll get 10 or 0.0, whatever that would be, 0.01. You get 10 milliseconds. But if you ask for time monotonic, it ties it to the system clock. And that's what I'll have to investigate.
That would be interesting, because on a robot I started at the early part of this year when I had the SBI. Remember the earliest meetings we had, we were talking about SBI ports. And the trouble was that on the Pi side, which I made as the SPI master, I was able to see using the oscilloscope on the Arduino side, the slave side, I was able to see that the Pi was varying all over creation. Now, I wasn't asking the Python on the Pi to do monotonic time, but clearly different processes on the Pi, no matter how timed that I had it on the loop of the Pi, whatever other things on the Pi were causing it to vary all over the place, and give me dramatically different results on the slave side.
Yeah, I'll dig up a link to a stress test that you should be able to run on your setup, Murray. And again, if you run that, like some off-the-shelf little utility that sucks up all available CPU time at sufficiently high priority, your Python code is just going to be dead in the water. That's the thing, right? With priorities and device drivers taking away CPU time, you don't have control over that.
Well, I realize this meeting's gone on a long time, so I think what we can do is take this off to the mailing list.
All right. There we go. Yeah, you've got a work day to get to, Murray. We've been holding you back.
Actually, my partner's waiting to make dinner. Actually, it's like 5:30 here. So
Oh, man. Well, we got to let you get on with that. So,
it was good to see all you guys.
All right.
gentlemen, great discussion. Have a good night, good day. Talk to you next Tuesday.
All right.
Thank you, guys.
Take
Bye.
care.
Bye.